Hello everyone. In this video, we'll go through the AZ204 study Cram, where we will go through the syllabus one by one. If you find a lot of added value from this video, please like and subscribe. With that being said, let's just get into it. So we will start off with the first section of the exam, which is Develop Azure Compute Solutions, and that forms 25 to 30% of the exam, which is actually the bulk of the exam. So what I'm going to do is I'm going to keep a copy of the syllabus right here at the top so we can make sure that we go through the syllabus one by one and have you guys covered for the whole exam. So under that section, we have four main topics, starting with IaaS and ARM templates. Then we're going to move to containers, then Azure App Service, and last but not least, we'll talk about Azure Functions. So starting with the IaaS and ARM templates, we have the section of provisioning virtual machines. Now, this exam is not really heavy on the virtual machines part, but there are some things that you need to take into consideration. So when we talk about provisioning virtual machines, there are a couple of things that you need to think about, or design considerations that you need to think about before creating a virtual machine. Now, the three factors you have to take into consideration are the CPU you have, the memory you have, and the IOPS. So the CPU is very useful for obviously process intensive tasks. So you want to choose a virtual machine that is compute optimized, which means that it has a higher ratio of CPU to memory. Or you can use a virtual machine that is memory optimized. So for example, a lot of times people use databases that are memory optimized because you typically want a memory optimized database. And then last but not least, you need to take IOPS into consideration. And IOPS is nothing more than just a unit of measurement for the SSD and the HDD. So those are the three things that you need to take into consideration as a developer if you want to develop applications on a standard IaaS virtual machine, which is, by the way, never a good idea. So moving on, the second topic I want to talk about super quick here is just the high availability. Again, as a developer, when you are developing applications on a VM, which is not a good idea, you need to think about high availability. So on Azure, we have like three ways to achieve high availability of your applications that are hosted on virtual machines. So the first thing is the availability set. The second is the availability zone. And the last one, which is not really part of the VM out of the box features, but you can use a separate service on Azure called Recovery Services Vaults, where you essentially back up your virtual machine into a separate region. Again, I'll go through that in detail. So starting with the availability set, the availability set basically places your VM into different racks in the same data center. Okay, so if there's a network failure in a specific rack, or if there's a hardware failure in a specific rack, your application will still be available because your VM is placed in a different tracks. So this is availability within a specific data center. Now, when we talk about availability zones, your VMs are replicated across different data centers in the same region. So the way this works is for a specific region, let's say it's West Europe, we typically have a lot of different data centers, typically 3 or even more. And the way this works is Microsoft places your VMs across those data centers in a specific location. So this does not provide regional high availability. So meaning that if one whole region goes down, that does not mean that the application is highly available. What this means is that if a specific data center is down, but not the whole region, then the application will still be highly available. So this is the concept of the availability zone. And the last one was with the Azure site recovery. This, with that, you basically have to rely on another service on Azure called Azure Recovery Services Vaults. And that would allow you to essentially replicate your machines across different regions. So if you're super paranoid. Let me go through the portal real quick and show you how we configure those settings. So under the create virtual machine part, you obviously have to specify the resource group and then you choose a name. And under the availability option, you can opt to not have any infrastructure redundancy required. Basically, you won't make use of the availability set or the availability zone or any of the things we discussed. Or you can choose either availability set, availability zone, or virtual machine scale set. So with a virtual machine scale set, it actually places your VMs behind a load balancer, so kind of giving it that high availability. So again, this probably explains it much better than I did. So with availability zone, it physically separates your resources within an Azure region, so across data centers. Availability set basically distributes your VM across server racks, which is what we call fault domains. So this is really how you configure the availability types. And on the Azure documentation, I will share a link below. We have some examples of VMs that are compute optimized, that are memory optimized, maybe that are general purpose, etc. So those are the things that you have to take into consideration when you are provisioning virtual machines. So moving on to Azure ARM templates, and you are expected to configure and validate and deploy ARM templates. But before I go deep into ARM templates, I just want to take a step back and talk about operations on Azure. So on Azure, we have two distinct types of operations. The first one is the control plane operations, and the second one is the data plane operation. So the control plane operation is basically the management operations. So what we call CRUD operations, the create, read, update, and delete operations. So when you create a storage account, for example, that is considered a control plane operation. On the other hand, for the data plane operation, those are specific functionalities exposed by a service. So for example, when you RDP into a virtual machine, that's a specific functionality exposed by a service, but it is a data plane operation, not a control plane operation. When you delete a virtual machine, that's a control plane operation. So on Azure, it is super important to distinguish between the control plane operations and the data plane operations in order to properly understand what an ARM template is. And on Azure, we have the concept of resource providers. So resources on Azure are organized by resource providers. And under each resource provider, we have a set of control plane operations and data plane operations. So in this specific example, we have the Microsoft.Storage resource provider, and under that resource provider, we have hundreds of operations being control plane operations or data plane operations. And actually in this specific example, this operation here is actually a control plane operation, but this one here is actually a data plane operation. And if I want to go real quick to the documentation just to show you a list of all operations under all resource providers. So if you go to this link, and I'll provide it in the description, you can see that under each resource provider, we have a lot of different operations. So here in this documentation, the data plane and the control plane operations are not really distinguished. So you might ask me, okay, so how do we distinguish between a control plane operation and a data plane operation? Or in other words, how do I know if this is actually a control plane operation or a data plane operation? And the easiest way to do that is actually if we go to the portal, and then if you go to access control, so this is a specific storage account. If you go to access control and then to the roles section, there's a role here known as Blob reader. So if I click this role itself, notice that we have actions and data actions. So under actions, we have the control plane operations, and under the data actions, we have the data plane operation. So this specific permission is actually considered a data plane operation, while those are considered a control plane operation. Now, if you want just something a bit more intuitive and maybe a bit easier for you to know about, typically, let's say 90% of the time, and again, this is not a hard rule, there are some exceptions, anything or any operation that is logged under activity log is typically considered a control plane operation. Anything that is not logged in Azure activity logs is typically a data plane operation. So when you are actually reading from a blob storage, that's not going to register an activity log event, okay? Because that's a data plane operation. Anything else should typically register an activity log operation. Again, that's maybe 95% of the situations. I believe it is good enough for the purposes of this exam. So that brings us to the question of what is Azure Resource Manager? Azure Resource Manager is the control plane and management plane in Azure. So any operation, any control plane operation actually goes through Azure Resource Manager. So any operation, whether that's done through the portal, through the CLI, through PowerShell, or through a REST API, obviously you guys know that anything you do on Azure at the end is just an API call, whether that's done from the portal, whether that's done from a script or from your application, everything is essentially an API call. And all control plane operations go through Azure Resource Manager. So, and again, that's why I mentioned resource providers, because under each resource provider, you have specific operations. So if myself from the portal, I want to find out the list of operations under a storage account, my portal would actually call the Azure Resource Manager, which then calls that specific operation under that specific resource provider. So the reason why we have this middle layer is because it deals with things like authorization, RBACs, and things like that. So again, any control plane operation will go through Azure Resource Manager. So anytime you are creating resources, this will go through Azure Resource Manager. Anytime you are reading resources, go through Azure Resource Manager. Anytime you're deleting resources, it goes through Azure Resource Manager. So now the important question is, what is an ARM template? So again, just like on the portal, you can create Azure resources, okay? Or you can create Azure resources using PowerShell, CLI. An ARM template is simply just a declarative way to create Azure resources, okay? So again, creating Azure resources is considered a control plane operation, okay? And that goes through ARM or Azure Resource Manager. You can create those operations, or you can access those operations through the portal, through the CLI, or through the REST API, but you can also do that through an ARM template. So with an ARM template, you basically declaratively define what resources you want, okay? Declarative means like you typically write that in a form of a JSON file, a YAML file, etc. In this case, it's a JSON file, so you declare what resources you want in advance. That's what we call declarative, okay? Now, the advantages of using something like an ARM template is, first of all, it is declarative. So the reason why it's important to have something declarative is because you can replicate the same template across different environments, okay? So you can have the same template be applied to a test subscription maybe, or a test resource group, and then you can have that same template be applied to a production resource group or a production subscription. So that's just because it is declarative, it makes things like replicating across different environments so much easier. Next, it is version control. So that's another huge advantage. So you can track the changes to this declarative file on things like GitHub, Bitbucket, GitLab, and all of that. So it is version controlled. It's always good to declaratively define your resources. Actually, this is best practice when you are going in production. So if you want to adhere to the principles of infrastructure as code, this is what we mean by infrastructure as code. So you are defining your infrastructure in a declarative file. So in this case, it is an ARM template, okay? Now, what are those sections in the ARM template? So again, this is just a JSON file, but there are certain properties that you need to understand. So under the schema, this is basically like built in. You can get it from the documentation, and basically this defines the properties available for this template. So under this specific schemas, you can define certain properties like variables, parameters, resources, etc. This is standard across every single template. Then we have the content version, and this is if you want to version your template. So if you want to have version 1, version 2, etc. If you want to make changes, that's a good property to take into consideration. Then we have parameters, and parameters are simply just a way to allow you to provide inputs to this template, okay? So again, a big advantage is that this template is declarative, which means that it can be replicated across different environments. So you can parameterize things like the resource group. So you can provide the resource group as an input because this is what you want to change across different environments, okay? Again, this is just a way to provide inputs to your template. This is the easiest way to think of a parameter. And for variables, this is when you don't want to hardcore things like let's say the resource group location, things like that. You want to store those in a variable because you will be using them across different resources. So variables, again, this is intuitive. The most important section is actually the resources section. And as you can see, this is an array of JSON objects. Okay, and this is where you actually define the resources that you want to create. So in this case, we have the storage account, and this is, by the way, all taken from the documentation. So I don't expect you guys to actually memorize every single thing here. This is all taken from the documentation. But if you want to create a storage account, you would have to put that under the resources array. Okay, and if you want to create more resources, you just have to add to that array. In this case, I'm just creating a storage account. You would provide the name, which is in this case storage account 1, and then the type, which is the resource provider / storage account, and then the API version. Again, that's taken from the documentation. And then here you would provide the location. And the reason why I'm highlighting this is because anytime you see a square bracket in an ARM template, that means that this is an expression. Okay, what do I mean by expression is just it's a way to easily access a specific object. So in this case, in order for me to easily access the resource group location object, I need to wrap this around a square bracket. Okay, so again, here, instead of typing, for example, West Europe, so instead of hard coding that, I can just type that I want the resource group location. So I want the storage account location to be the same as the resource group location. This is an example of an expression. There are so many other different expressions. Those are all linked in the documentation. Then we have the tag section, obviously, if you want to tag your storage account, and then just the standard properties. In this case, what account type am I choosing? And last but not least, there's the output section. And this is if you want to define a specific output from your template. Typically, the goal of the template, again, is not to really specify an output. It's usually just to create resources on Azure. In this example, it is a storage account. And by the way, when you deploy this template, behind the scenes, it actually converts that into a series of REST APIs. Because again, anytime you are creating a storage account, at the end, this is a REST API call, whether that's from the portal, whether that's from PowerShell, and even from an ARM template. So when you deploy this ARM template, it actually creates those REST API codes behind the scenes for you. Okay, so this is just a fun fact. And if I want to go through a quick demo here, I just want to show you a quick example. So this is an example that I took from the documentation that will allow me to create an API management service. Okay, so under this template, again, the schema is just standard, the content version. In this case, I don't want to version my template, so I'm just going to keep it as it is. The parameters section, under that parameter section, we have a list of parameters. So in this case, I do want to provide inputs to this template because I want to replicate this across different environments. So I want, for example, the API management service name to be different in the test environment than in the production environment. So I am parameterizing that. Okay. Of course, here you can provide default values for the parameters. So if you did not add any value, or if you do not provide an input to this template, it would just choose a default value. In this case, again, there's a square bracket, which means that it is an expression. And here I'm just creating just a random name for this API management service. And then the publisher email, I have another parameter, publisher name, SKU, and all of that. Again, I don't want to go through those one by one, but it's always useful to go through that in a live example. And under the resources section here, I want to create an API management service. So I'm going to have an API management resource here. So again, I specify the type, the API version, all taken from the documentation. The name is actually taken from the parameter. Again, I would have to use an expression for that to tell the template that I'm using this from a parameter, and the location and the SKU, the properties and all of that, all of those are from parameters. Okay. So now what I can do is if I want to deploy this template, I can use PowerShell or I can use Azure CLI. In this case, I'm using Azure CLI. So what you would type is AZ deployment group create, and then you would type the name of the deployment itself. So that's not the name of the resource. That's just the name of the deployment. Every deployment is just going to have a name. In this case, I'm specifying a name of test. And then you specify a resource group. And in the case of ARM templates, you can either deploy that template into a subscription or a resource group. The best practice is to actually deploy it into a resource group. In this case, I'm deploying it to this specific resource group. And then I'm specifying the template file, which is arm.json. And I am specifying a parameter file. So here under the -- parameters section, I can explicitly define the parameters right here from this command. Okay. But the best practice is actually to provide those parameters in a separate parameters.json file. Again, this is taken from the documentation, but this is the syntax on how to do it. So you would actually define the parameters. In this case, I'm defining the API management service name of that. Okay, and the publisher email, publisher name, and the SKU, I'm doing that from a separate parameter file. And then I'm supplying that parameter file to this command here, or to this deployment. And if I click run, it will actually create an API management resource for me. I'm not going to do it because I already did that, but I just wanted to show you guys a live demo of that. Next, we have the concept of a multi-tiered template, and I've saw a couple of different questions on this section. But what you need to know is you can basically nest template under a parent template. Okay, so for example, if you want to be creating multiple resources under the same ARM template, the best practice is not to put every single thing onto the same template. The best practice is actually create separate templates for each resource and then have a parent template that calls those nested templates. In this example, I'm creating a virtual machine, an app service, and a SQL database into a specific resource group. Now I can have all of those under the same ARM template, or I can have them under different ARM templates and have a parent template call those nested templates. Just wanted to highlight that because I saw a couple of different questions on that on the exam. Then we have the deployment mode, and we have two different deployment modes with Azure ARM templates. The first one is the incremental mode, and this is actually the default one. And what this means is that this will leave resources in a resource group or subscription, depending on what you specified. This leaves them unchanged if they aren't described in the template. So let's say I have a template that creates a storage account, okay, under a resource group. Obviously, if I have virtual machines under that resource group, or if I have SQL databases under that resource group, I want those to be unchanged, because in my template, I'm just creating a storage account. I want to leave everything else the same, okay? This is the incremental mode and the default mode. However, sometimes you want to have, like, let's say, a single source of truth for your ARM template. You would go with the complete deployment mode. So what this means is that if the resource is not in the template, it actually gets deleted, okay? And in order to do that, you have to explicitly specify the mode with -- mode complete, because the default is the incremental. So be careful. If you are using the complete deployment mode, it will literally delete every single thing in your resource group if you did not specify it in the template. Now let's move on to what is a container. Okay, so I've made a detailed video on what a container is, and I talk about Kubernetes and AKS. So make sure to watch this video. I'll link it here at the top. But in a nutshell, what a container is, it's just a layer of abstraction above a virtual machine. So you know, with a virtual machine, you have the concept of a host machine, and then you have the concept of virtual machines being built on top of that host machine. Each virtual machine is going to have its own guest operating system. The difference between a container and a virtual machine is that you don't have the concept of a guest operating system. So there's no guest operating system. It's much more lightweight. It packages all the dependencies together into a single container, so we can run it across multiple environment, and it is the de facto standards for microservices. So anytime you are developing microservices, you would have to be using containers. But again, like, the main benefits is that it is lightweight and it packages every single thing into one container. Okay, and again, I made a detailed video on that. Please make sure to watch that. But if you want to create a container, okay, there's a specific workflow that you have to follow. And again, there are a couple of different questions on the exam about how to create containers, or what is the typical format of the file. In this example, I'm going to go through a quick one, which is a Node.js application that I want to containerize or create a container out of. Here at the top, you would have the base image. So think of, let's say, if you want to install let's say, any application on your operating system or on your machine, you would need to have an operating system at the top. Okay, so you just can't just install, for example, Microsoft Edge on a machine with no operating system. So you need to have a base operating system. This is the same in a container. You need to specify a base operating system. In this case, it's Node 16. It could be a Ubuntu machine. It could be anything. Okay, so this is, again, the base operating system. Here, there's just a series of commands that you have to go through. So the first one is I'm specifying a working directory for my application. So I want my application to be inside this directory in a container, okay? And then I'm just copying my package.json file, which has all the dependencies. I'm installing all the dependencies. And then I'm copying every single thing from my current directory and putting it into the working directory. This is what it means here. Here I'm exposing port 8080, and then I'm running the startup command. Okay, so the startup command is the command that runs your application. In Node.js, it is node and the file name. Okay, so this is the startup command. Again, in my other video, I actually explained the container as being a file system snapshot. This is exactly what we're doing. We're literally just copying everything from the directory, putting it into a specified working directory that I specified. I'm copying, I'm installing all the dependencies, and I'm running the startup command. Let's see this in a live demonstration. So here I have my application folder. It's a very simple application, but if I want to type npm start to run my application, this application is actually running on my local machine. So if I go to the browser and I type localhost 3000, I will have this working application. But again, at the end, it's running on my own personal laptop, okay? What if I wanna have this application run inside a container, so not on my machine? I would obviously have to containerize it, and the most popular platform for that is Docker. So just make sure you have Docker installed The quickest way to check if you have Docker installed is just type Docker. And if you see those help commands, that means you have Docker installed. If not, you need to install it. Super easy, just with a quick search on the internet. So the way to create a container out of this application, or the way to containerize this application, that's the correct terminology, is to define the Docker file. And again, I went through this in detail, but in this case, again, I'm specifying base image, work directory, I'm copying the dependencies file, and I'm installing all the dependencies, and then I'm running the startup command, which is npm start in my case. Okay, so now if I want to apply this Docker file into my current directory, I would type docker build -t, and what I'm doing is I am actually tagging my build, or tagging my container with this specific name. Okay, I don't want just a random GUID, I just want a specific name, and there's a reason why I chose this specific name. It will make sense later on. And then I specify the current directory I am in with the dot, which is everything under my current directory. So I type that, and then let's wait for that to run. And now I should have an image with this name. Okay, but I need to run an instance out of this image. Okay, again, there's another definition for a container. It's actually an instance of an image. Okay, so right now we have the image. We need to run an instance out of this image. So what I would do is I would type docker run and then the name. So .azure.cr.io test v1. And by the way, something I forgot is when you type docker run, you need to expose the ports here. So what I'm doing here is I am exposing the ports in my container, because otherwise I won't be able to access this container that is running locally. So what I'm saying here is expose my container on port 443, and my application is listening on port 443, which is the case here. My application is listening on port 443, but I want to access the container on that port as well. So this does like a port mapping. Super important. Then if I click run, as you can see, app is listening on port 3000. Now my application is actually running inside the container. And if I go back to the browser, I can see that the application is still working fine. But the difference is that previously my application was running on my local laptop. Now it's actually running inside a container. So right now I have my container running locally, or I have my container image running locally. Obviously, this is not the best practice. You always want to store your container in what is known as a container registry, which is a centralized place to store your containers in. Okay, this is super important because if you want to get into things like Kubernetes, a service like Kubernetes is actually going to pull containers from a centralized container image registry. Okay, so right now I have my container image stored on my local laptop, but I do want to push that into a centralized container image registry. Okay. The way to do that is we can use a service called Docker Hub, or if you want to use an Azure service, it's called Azure Container Registry. I will explain more about that in detail, but let me go through a quick demo because this will make much more sense. Okay. Now, the first thing I have to do if I want to push this container image to that centralized repository on Azure is I have to type AZ login to make use of the AZ command line and to authenticate to my Azure Container Registry. I'm not going to do that. I already did, but make sure to run AZ login before doing any of the subsequent steps. Then I would type AZ ACR login and the name of the Azure Container Registry resource. Again, I'm going to explain that resource in detail later on, but I just want to go through a demo super quickly. So here the login succeeded, which means I am authenticated to the Azure Container Registry. This could be a Docker Hub, by the way, or any other container registry service you are relying on. Then all you have to do is type docker push and the name of the image you have locally, the one that I tagged. Okay. Now the tagged image I have is, pardon me, it is this one. So docker push the image that I have that is tagged. And if I type that, it is actually pushing this to Azure Container Registry. Okay. So now if I go to the portal, I have a container registry resource created on Azure, and under the repositories section, I should see the image that I pushed. And as you can see, this is the image that I actually pushed, and it's with a specified version that I have. So now my image is not stored locally on my laptop. It is stored in a container registry. In this case, it's Azure Container Registry. Now, under Azure Container Registry resources, for the purposes of this exam, you need to concern yourself with two things. Firstly, the pricing tier and just the storage capabilities of Azure Container Registry. Now, we have a couple of different pricing tier. The first one is the basic pricing tier, and here you don't have a lot of included storage, an image throughput. What do I mean by image throughput is, again, when you start dealing with things like Kubernetes, container instances, things like that, in order to create instances out of the images stored in that centralized repository, there's a certain image throughput, because sometimes that takes time to transfer that image and create an instance out of it. So that's known as the image throughput. In this case, you don't have much of it on the basic tier. Again, this is just meant for developer workloads, not for production. The standard provides more storage and image throughput, so that's a different, and this is actually meant for production workloads. The last one is the premium feature. This adds all the features of the standard, but it adds extra features like geo replication and private link support. So with geo replication, you would actually have your images replicated geographically across regions. So if there's an outage on this specific region, your images are actually still going to be available. Again, this is part of thinking about your disaster recovery and high availability strategy. Last but not least, there's also private link support. I will be talking about private link later on in this module, but I'll leave that here for now. And then we have the storage capabilities of Azure Container Registry. So those are the standard storage capabilities across all the tiers. So what you will get is encryption at rest storage. So everything is encrypted at rest on Azure Container Registry. And then you have geo-replication of storage, obviously if you are using the premium tier as discussed. And you need to know that the limit of storage is 5 terabytes, which is actually a lot. Last but not least, in the topics of containers, we have Azure Container Instance. Now, an Azure Container Instance is a resource on Azure that allows you to run containers in a serverless way. So if you are familiar with Azure Functions, where you can run your function in a serverless way, Azure Container Instance is a serverless service on Azure that allows you to run containers on it. Now, you might ask me this question, and this is a question I asked myself a lot. Okay, so why do I have Container Instance, which is a serverless way to run containers, if we can run containers on Azure Functions? So what is the difference? And the difference between those two is Azure Container Instance is typically used if you want a long-running application or a long-running container. With Azure Functions, it's typically shortly executed processes. Okay, so you just want a specific thing to be executed, you can package that into a container, throw it into Azure Functions. But with Azure Container Instance, it's also serverless, but it's meant for long-running containers. Like you can host a whole application just on Azure Container Instance. Okay, so again, that's the difference between running a container on Azure Container Instance or on Azure Functions. Now, under Azure Container Instance, you have the concept of container groups, which is a way to deploy multiple containers in a container group. Okay, typically in a container instance, you just run one single container. Okay, but with the concept of container groups, you can deploy multiple containers into the container group. This is very similar to the concept of a pod in Kubernetes. So again, I have another video that goes into details on that, so make sure to check it out. Lastly, we have stateful containers. So by default, Azure Container Instance is stateless, which means that there isn't a way to store local information. So you can't write things into a variable, you can't store session information, you can't write into a local cache, things like that. So in order to do that, you can mount Azure file shares, okay, to allow containers to persist their state. Anytime we see those confusing words like mounting file shares and things like that, mounting just means that we are making Azure file share available to the container. That's all it means. So mounting Azure file share, I am making Azure file share available to that container. Again, if I want to store persistent information. Obviously, you can use external caches like Azure Redis cache and things like that. And here in the portal, I can create a container instance resource where I specify the resource group first, and then I provide a name, a region, and here I can choose the image source. So the image source can be just a quick start image from our standard images and the marketplace, and it can be an Azure Container Registry or a Docker Hub or any other registry you are using. In my example, I'm using an Azure Container Registry stored image. In this case, I choose the registry, which is this one, and then the image name, which is test. And then I go ahead and deploy that. What it will do is it will pull the image from the container registry into this container instance, and you would have an application hosted on container instance in a serverless manner. So now let's talk about Azure App Service, which forms a big chunk of the exam. So Azure App Service is a platform as a service on Azure. And essentially, you probably know the difference between infrastructure as a service, platform as a service, software as a service. I don't want to spend too much time on this one, but the way I like to think about it is in terms of control. So the higher you go up the ladder, the less control you are being given. Okay, so with infrastructure as a service, you essentially get the physical hardware, but you still have to manage the updates, the middlewares, the runtimes, etc. With platform as a service, all you have to do is just write the code, and Azure manages the rest for you. And obviously, we have the software as a service, which where essentially everything is managed for you. So Azure App Service is actually one of the first services that were created on Azure. It was previously called Cloud Services, and this is what Azure actually started with. So this platform is actually very useful when you are hosting just traditional classic n-tiered web applications, which can actually be the majority of your use cases. So essentially anything other than microservices is actually recommended to host on Azure App Service. And by the way, you don't need a microservices architecture for every single application. You're actually much better off starting with Azure App Service, which is super easy to work with, and it will give you all those benefits of developer productivity, scalability, and it can handle really a lot of high load. So that's where Azure App Service is used. Definitely, it's more recommended to use Azure App Service than just infrastructure as a service, where you're hosting your application on a VM. This is never a good idea, as I always say. And when you use Azure App Service, you get access to a couple of important features. So the first feature is just built-in autoscale. So you can essentially easily autoscale your applications, where you add more instances depending on a specific condition, like let's say the percentage of the CPU of your host machines. Next, you have the concept of deployment slots, which I will talk more about later. But here you can essentially segment your environments into staging environments, production environments, test environments, etc. Next, you have just the out-of-the-box continuous deployment, short for CD. So you can hook your Azure App Service resource into a source control repository like GitHub, Bitbucket, Azure DevOps, etc. And you just get out-of-the-box continuous deployment with really no effort from your side. Lastly, you also have the ability to host containers on Azure App Service. Next, let me talk about the resource hierarchy. And what I mean by resource hierarchy is, how is the Azure App Service resource organized in Azure? So essentially, your Azure App Service resources are organized under what is called an Azure App Service plan. So your Azure App Services are actually created under what is called an Azure App Service plan. Okay. Now, if I zoom into this app service plan, we essentially get this sort of environment. So an app service plan is essentially an environment containing of worker nodes where the applications are actually running, but also there's things like load balancers, which are known as front ends, some file servers and other servers, etc. So this is all a shared environment, or what is called a multi-tenant environment. And what I mean by multi-tenant environment is this environment is actually shared with more than one customers. And actually, most cloud providers go with this multi-tenancy model because it just gives them the best return on investment. This is just the way it works nowadays. But with Azure App Service Plan, you have different level of controls. So if you're going with just the basic tier, every single thing is shared. So the VMs are shared, the load balancers are shared, the file servers are shared. All of this environment is actually shared. But if you go with the production level tiers, everything is shared in terms of networking. So the load balancers are shared, the file servers are shared. All of those actually, you don't see them behind the scenes, but the VMs themselves are actually dedicated to you. And this is actually the most important thing, and it actually satisfies most of the scenarios. But with Azure App Service, you also get access to the isolated tier, which essentially gives you your own virtual network, where you can deploy your own load balancers, your own file servers. Everything is essentially for you. So nothing is shared. It's a single tenant. Everything is given to you. So that's the isolated tier, which I will speak more about later on. Now, when it comes to Azure App Service Plan, it defines a couple of different things. Firstly, it defines the region where your applications are hosted. Then it defines the number of VMs you need in your Azure App Service Plan. And lastly, but most importantly, it defines the pricing tier. And when we talk about pricing tier, we have a couple of different pricing tiers. So the first one, which I touched on briefly, is just the shared compute, where all the applications are running on the same single instance, same shared environment. All of the customers are sharing this. Obviously, this is meant for dev test environment, nothing production ready. Next, we have the dedicated compute. And with dedicated compute, you essentially get a shared network, but dedicated instances, as I mentioned in my previous slide. Now, the higher the tier here, the more VMs you can spin up and the stronger the VMs you get, essentially the stronger specs you get. So just to touch on them briefly, we have the basic tier, which does not support Autoscale. We have the standards tier, which does not support private endpoints. And then we have the premium tiers, which do support Autoscale. They do support private endpoints. And the higher you go in versions, the stronger VM specs you get access to. And lastly, you have this isolated environment, which I spoke about briefly, where you essentially get your own dedicated virtual network and instances, where you run this in a single tenant, completely isolated from other customers. So if I want to show you that on the portal really quickly, I have my Azure App Service resource, and under my Azure App Service resource, I can navigate to the App Service plan itself. And as I mentioned, under an app service plan, you can have a bunch of different Azure app services, which represents your applications. So if I go to the apps section here, I can see we have 2 different Azure app services running under this Azure app service plan. And I have a couple of different deployment slots, which I will talk more about later on. So if I want to quickly show you this scale up section, here you can see the different pricing tier, which I spoke about. And Azure makes it really convenient for you where they separate it into dev test, production workloads, and just this isolated workloads. And you have different tiers under those big segments. Next, I would like to talk about diagnostic logging or diagnostic settings, which is actually mentioned a couple of times in the exam. So diagnostic settings is actually a way to send resource-specific logs to either those 3 destinations, which are Azure Log Analytics, Storage Account, or Event Hub. So essentially, most resources on Azure, like Azure App Service, Storage Accounts, Automation Accounts, Event Hubs, etc., they expose certain logging, okay? But you actually don't have access to those logs unless you export them to either of those destinations, which are Log Analytics, Storage Account, or Event Hub. So essentially with Azure Log Analytics, this is best used if you just want a query mechanism where you want to query your logs. You want to create things like alerts where you want to respond to the logs. You use Azure Log Analytics for that. But if you just want those logs for archival reasons, you typically just throw them into a storage account. Lastly, you have the Event Hub, and this is meant for having applications consume those events or those logs. So you can essentially have like diagnostic settings configured on an Azure App Service where it sends logs to Event Hub, and you would have another application, let's say Splunk, which is a third-party logging system that consumes those logs where you can query them later on. So again, just a couple of different use cases here. But with Azure App Service resource specifically, there are a couple of different logs that you can expose and export to those destinations. So the first one is just the application logging, and here you can see all the descriptions. These are basically just the log messages generated by your application code. You have the web server itself logging, so those are the raw HTTP requests. You can have detailed error logging, failed request tracing, and deployment logging. And here you can see what platform is supported for that. And if I want to show you that on the portal, if I can scroll down here and go to diagnostic settings, as you can see here, you can configure a couple of different endpoints. So basically, if I click on add diagnostic settings, I can choose either of those endpoints. This is sending to a partner solution. This is actually recently being developed, but essentially you can actually choose those logs that I spoke about in my previous slides. So this is where you create the diagnostic settings. These are the categories that you choose. And here is the destination that you configure. Okay, pretty simple stuff here. Next, I want to talk about deployment in Azure App Service. So how do you deploy your code to Azure App Service? So essentially you have 2 methods. The first and the recommended one is the automated deployment. And here you have out-of-the-box integration with a source control repository like GitHub, Azure DevOps, Bitbucket, etc. So anytime you merge changes into a master branch, the code actually gets deployed automatically to Azure App Service. So in other words, anytime you make changes to a source control repository, those changes are actually deployed to Azure App Service automatically. And this is actually the recommended way to go about this in production environments. Next, we have just a simple manual deployment, and where you just have your application code. You can use Azure CLI for that. You can use zip deploy using our Kudu API. You can transfer it through FTP, and you can also deploy it from Visual Studio, which I find is the most convenient method for that. So if I want to show you a quick demo on how we would deploy the code to Azure App Service using Visual Studio Code in this example, you would have to install an extension called Azure, and then once you install that extension, you would have access to this tab. And essentially all you have to do is just click deploy to web app. So you would choose the folder where your application code is written in, and then you would choose the subscription, and then you would choose the specific web app itself. In this case, it's this one, and it will just automatically deploy it. Next, if I want to talk about the automated deployments, which is from a source control repository, all you have to do is just go to Deployment Center, and all you need to do is just hook up your app service resource to a source control repository. In this case, here I'm already connected to a source control repository in GitHub. I have my test repo repository, and I'm choosing the main branch. So now, anytime I make changes to this main branch, or anytime I merge changes to this main branch, the code will get deployed to Azure App Service automatically. And again, this is the recommended way to go about deployments on App Service. Next, I want to talk about the concept of deployment slots. So I touched on the resource hierarchy on Azure App Service a bit, but if I want to expand on this a bit, we have the Azure App Service plan, and underneath that App Service plan, we have the Azure App Service resource. And under that Azure App Service resource, we have what is called deployment slots, which are actually the place where, or the slots where your application is actually running. Okay, so you can have things like production slots, which are there by default without you having to do anything, but you can create extra slots like staging slots. So essentially, you can deploy your application into those specific slots. So the unit of deployment in Azure App Service is actually the slot itself. It's not the App Service plan. It's not the Azure App Service resource itself even. It's actually the deployment slot. Okay, so you can deploy your application into a production slot, into a staging slot, and there are many different use cases for that. The most common use case is obviously anytime you want to deploy into production, it's never a good idea to deploy immediately into production because there's always downtime for that. The way this works is you would first deploy it into staging. You would make sure everything is working fine in the staging environments, things are not breaking, etc. And then only after that, you would swap the staging environment with the modified code with the production environment. Okay, so essentially once you swap that, all it does is just a DNS entry change, nothing more than that. So you won't experience any downtimes. You will have more confidence because you actually deployed your application to a staging environment. You made sure that you did not screw things up. And look, if you end up screwing things up, you can just go back to the previous slot. So essentially all of that is easily managed in Azure App Service. But one of the interesting things you can also do is things like A/B tests. So you can essentially divide traffic between your slots to do things like A/B tests. So you can have 50% of the traffic go into production and the other 50% of the traffic go to production 2, for example. And if I go back to the portal and I go to the deployment slots section, in this case, you can see 2 different slots here. So automatically you will get the regular slot, which is the production slot, but you can optionally add new slots. In this case, I have this staging slot. And if I click on this staging slot, it's actually just like a different app service resource, essentially. Like from a UI experience, it looks like it's a different Azure App Service resource, but it's actually under the same Azure App Service. It's just a different slot. So again, you deploy your application into a slot, whether it's the production, whether it's the staging one. So best practice is you would have your code, you make the changes, you deploy it into the staging environment, you make sure everything is working fine, and at the end, all you do is just swap it with the production environment. And if you screw things up, you can just swap it back again. Your users will not be impacted at all. And as you can see here, here's where you control the traffic. In this case, 100% of the traffic is going through to production. Lastly, a very important topic to talk about in this exam is Autoscale. Okay, now there's a very small disclaimer here that I've written, which is actually something that a lot of customers get confused about. So Autoscale does not solve all your problems. Okay, just because we have Autoscale, that does not mean that it's going to solve all your problems. It's going to give your users the best experience. You don't have to worry about anything. So Autoscale helps when the server itself cannot handle the number of requests, okay? But it doesn't help with resource intensive tasks. So let me explain that. So usually Autoscale is helpful when there's literally not enough TCP sockets that a server can handle, okay? That's useful because you can just spin up extra servers, your users won't get impacted, new requests will still be served, okay? But if you have resource intensive tasks on a very weak machine, adding more machines is not going to make a difference because those machines are essentially just weak. Okay, so I hope that makes sense. In a nutshell, Autoscale is super helpful when you are dealing with a very high traffic, but it doesn't mean like you can choose a very low VM spec and you can just configure Autoscale and have things easy for you. You do need to think about this a bit. So it's not as straightforward as people think it is. So Autoscale resource on Azure, okay, is actually under the resource provider. Remember, we spoke about resource providers before. It's under the Microsoft.Insights resource provider, okay? So it's essentially just an Azure resource, just like Azure App Service, just like storage account. At the end, Autoscale is just a resource on Azure. That Autoscale resource on Azure can be configured on a couple of different resources, okay? So in other words, it can scale a couple of different resources on Azure. So those can be API management, those can be Azure App Service, those can be just standard virtual machines. So again, it's just a different resource on Azure. It's like it's applied on the Azure App Service resource itself, but it's not essentially tied to it, if it makes sense. It's a completely different resource provider, okay? So the Autoscale resource itself, with that, you create rules based on those condition types. So you can autoscale based on a metric, okay? So essentially you make decisions based on a certain metric. That metric can be the percentage CPU on an app service plan. It could be the number of HTTP requests, etc. So you're essentially making decisions based on a metric, okay? But you can also scale to a specific instance count based on a schedule, okay? The perfect example is Christmas time. Look, your store is crazy, has crazy traffic during Christmas time. You don't want to make auto-scaling decisions based on a metric because you just know that during Christmas, you just want more instances running just in case, okay? So you can configure a rule where you scale to a specific instance count based on a schedule, not a metric, okay? Also, spoiler alert, you can actually configure it based on both conditions. So you can have a condition where you scale it on a metric. You can have another condition where you scale it to a specific instance count. So you can have both under the same auto scale setting, okay? And multiple conditions are actually treated as an or, not as an and, okay? So it's either or, okay? And if I want to demo that quickly on the portal, I would go to, if I search for auto scale here, I would go to scale out, okay? So under scale out, I can configure the auto scale setting. So there's manual scale where I can just choose the instance count manually, or I can have custom auto scale, which is the auto scale that I've spoken about, okay? And you would give it just a name, under a resource group. Again, this is just a resource on Azure. And then you would choose whether you want to scale it based on a metric or to a specific instance count. So if I want to scale based on a metric, I would add a rule here under add rule. And here you can choose the metric source. That metric, by the way, can be any resource on Azure. It doesn't have to be an Azure App Service metric. You can actually make decisions on a metric, on a virtual machine metric, which is completely different. I know that sounds crazy, but you can actually do that. So you can choose any metric on Azure. Obviously, it's typically used for the actual Azure App Service metric because that is what you are designing on. But usually you can have it on the actual App Service plan or the Azure App Service resource itself. Okay, so you have both options. Essentially, here you would choose the App Service plan, the aggregation, and then here you choose the different metrics. So it could be CPU's percentage, data in, data out, and then here you would define basically the threshold. Okay, so let's say if it's more than 70%, you want to increase the instance count, let's say by 2. Okay, and then you would have a cooldown time. Okay, the cooldown time essentially in this case it's 5 minutes. what this means in a nutshell is anytime the autoscale rule is triggered where it adds some instances, it takes some time for that to be adjusted. Okay, so there's typically like a cool down period after that for like 5 minutes, which basically instruct the autoscale to not make any decisions for those 5 minutes. Just like when you cool down after your workouts. And obviously here you can scale to a specific instance count. You know, you could have that, and then you would create a schedule based on that. Again, super simple, super intuitive to navigate with. Let's talk about Azure Functions. So Azure Functions is the serverless offering on Azure that allows you to run event-driven functions. Now, as you can see, there are a lot of terminologies here. So let me break them down one by one. So what do we mean when we say serverless? So when we say serverless, that does not mean that servers are not used. Obviously, there are servers always behind the scenes. But when we say serverless, what we mean by that is you don't have to think about the hardware at all. Okay, so the platform takes care for you. So essentially with Azure Functions, all you have to do is just write the code and that's it. Okay, it's the same with Azure App Service. So you just essentially write the code, but on Azure App Service, you still have to choose like the VM specs, which tier you want to use, based on the VM specs, etc. So you still have to think about servers. Okay, with serverless, essentially it means that you don't have to worry about the servers at all, and it handles things like scale for you without having you actually worry about that and using certain rules, etc. So it's essentially just a layer of abstraction above platform as a service. So it's between platform as a service and software as a service. Okay. Now, what do we mean by event-driven functions? So serverless is best used for event-driven applications. What do I mean by event-driven applications? Is applications that respond to something, or specific functions that respond to something. So that can be a blob storage upload. That could be a database record addition. That could be an API call. So anything nowadays is considered event-driven, and Azure Functions are perfect when you want to execute something specific in response to an event, while not having to think about any servers at all. So that's in a nutshell what Azure Functions is. Okay. Now, with a more technical terminology, serverless means it's consumption-based. Typically, it means that it's consumption-based, meaning that you only pay for what you use. Okay. Second is you don't have to worry about servers at all, which is what I've explained previously. And lastly, it scales automatically out of the box. You don't have to configure anything. Everything is done out of the box. Now with Azure Functions, you have a couple of different hosting plans. So I've organized it into hosting plans on the left and the use case for that, okay? The first and most common use case is the consumption plan, okay? Which actually qualifies as a serverless platform. This is the default one, and you basically pay for exactly what you use. Super cheap. I think you get like 1 million executions per month for free. So it's super cheap. It's the default one. You pay for exactly what you need. And the maximum timeout in this is 10 minutes per function. So you can't go more than that. There's no virtual network integration with that. And it has what is called as cold starts. So because you only pay for what you use, the Azure Function app itself can scale down to 0 when there's no usage. And because it scales down to 0, once it's used again, it takes some time to spin up and provision the resources to accept the requests. Okay, so if your functions are super sensitive and you don't want them to be prone to cold starts and you want them to be executed immediately, you would have to look into other plans. So here the use case is you don't need the features of other tiers. That's basically it. So you want to pay for what you use and you don't want the features of other tiers, which I will touch on now. So we have the premium plan, okay, which is the second tier. And here you get predictable pricing per month. So this is what you're used to with app service, with VMs, etc. You get essentially predictable pricing. Okay, some customers prefer that. But most importantly, you get no timeouts. It supports VNet integration. And the most critical one is that the instances are pre-warmed. Okay, so the function execution is immediate. There are no cold starts. There are no things like that. But you would have to pay a fixed monthly fee no matter how much you're using the function. Okay, so this is different than the consumption. The use case for that is short but frequent executions. Okay, so if you have a lot of short but frequent executions, you don't want things like cold starts. You want pre-warmed instances. So this is a good use case for that. Okay. Another use case is you want seamless access to VNet resources. You would use premium plan because there is VNet integration. Lastly, we have the dedicated plan. Okay, now the dedicated plan, it essentially runs the function app itself in an Azure App Service plan. Okay, simple as that. Same as you would run Azure App Service on an App Service plan, you can also run Azure Functions on an App Service plan. Okay, you have no cold start issues because obviously, you know, you're using it in an App Service plan. Okay, the instances are already there. There are no timeouts, etc. So the use case for this is underutilized App Service plan. So if you have an App Service plan that's strong enough, it's underutilized, feel free to use it for your function apps as well. And another good use case is actually having Azure Functions in its own VNet. So Azure Function itself is actually not deployed in a virtual network. So with the consumption and premium plan, the function itself is not deployed into a virtual network that you control. Okay, but with dedicated, you can run it on an app service plan under an isolated tier. And the use case for that is you can run Azure Functions in its own VNet. Okay, so if this is a requirement for you, this is a good option to go with. Next, I want to talk about the resource hierarchy of Azure Function apps. So the way this works is you still have an app service plan. You don't deal with that a lot. You typically just do that to configure some network things like VN integration and things like that. But the bulk of this is you have a function app resource, and under that function app resource, you have different functions, okay? Different code functions, okay? Now, usually I've seen customers use just one function per function app resource, okay? Similar to how you would use like one app service resource under one app service plan, okay? This is similar, but essentially you would have multiple functions under the same function app resource as a way to organize similar functions together. So that's the way it's used. And if I want to show you that on the portal super quickly, I have the function app resource itself, and under that I have two different functions that I've created, and I can see that I can go also to the app service plan itself, and I can see the in this case like the function apps that are underneath this app service plan. So not the functions, the function apps themselves. And here I can configure things like VN integration and things like that. I can scale it up by changing the tiers, so from consumption to premium, etc. There are some restrictions from changing from premium back to consumption, so that's something to be aware about. And here with the scale out, notice that you don't have any autoscale rules or things like that. Like what you can do is basically just control like the maximum number of instances and the maximum burst. Okay, so you don't have any like metric conditions, schedule conditions, etc. Everything is handled out of the box. Next, let's talk about triggers and bindings. So on Azure Function, we have the concept of a trigger, which is the thing that triggers the function itself. And you can only have one trigger per Azure Function. Next, we have what is known as bindings. And this is a way to declaratively define inputs and outputs from your Azure Function. So it's simply just a way to make it easier to connect to different Azure resources. Okay, so this will make more sense in this diagram here. So a simple example is having a service bus queue trigger. So in this case, anytime a message is written to this service bus queue, the Azure function will be triggered. Okay, so this is an example of a trigger. Okay, now here we have a couple of output bindings for this Azure function. So in this case, it's Cosmos DB output binding and Event Hub output binding. And when you declaratively define those in Azure functions, it just makes it super easy for Azure function to connect to those Azure resources. So you don't have to rely on the Azure SDK and configure all of that by yourself. Bindings just make it super easy to natively connect to those Azure services in a seamless way. So here on the right, you can see a couple of different examples. So whenever a new queue message arrives, it runs a function to write to another queue. In this example, the trigger is a queue and the output binding is also a queue. Here you have a scheduled job which reads from blob storage contents and creates a new Cosmos DB document. In this case, the trigger is a timer because it's a scheduled job. And the input binding is blob storage because you are reading from blob storage. And the output binding is Cosmos DB because you are creating a new Cosmos DB document. Okay. Now, certainly in your function code itself, you can just use the Azure SDK and connect to blob storage and connect to Cosmos DB documents, but but bindings just makes this experience like just super easy to start with. So here is a quick example of how bindings are actually created. So in most programming languages, it's actually created using a JSON configuration file. Okay, so in this example, it's a Node.js file. If it's C#, it actually uses a decorator to create that. So in this example, I have an HTTP trigger with a direction of in, okay? And I have an HTTP output binding. And the reason why I have an HTTP output binding is because I want to respond back to the client with a specific JSON body. That's why we have an output binding as well for HTTP. But in this section, we also have the output binding for Cosmos DB. And how do you know that? It's from the type, which is Cosmos DB. And this is all from the Azure documentation, by the way. And here you define the direction, which is output. And this gets translated into this diagram here, where you have an HTTP trigger triggering this Azure function, which then does some logic and then writes to a Cosmos DB resource on Azure. And if I want to show that experience in Visual Studio Code, you can actually develop your Azure function resources, obviously on Visual Studio Code, and you'd have a very nice experience for that, where you can debug it on Visual Studio Code, you can run it locally, etc. So in this case, I have 3 different Azure function resources, and underneath this specific Azure function resource, I have 2 different functions. So one is called Blob Trigger 1, the other is called HTTP Trigger 1, okay? Now, there are 2 important files that you need to take into consideration. The first one is the host.json file, which is a global config file that is applied to all functions under an Azure function app resource. So things that can be defined here is essentially, for example, like number of concurrent HTTP connections, like the sampling in app insights, etc. So it's just a global config file that's applied to all functions under the same Azure function app resource. Next, we have the local.settings JSON. And here you define things like your connection strings, your secrets, etc. Again, it's just a config file that's that allows you to read from it using, like, let's say, connection strings and things like that. This will make more sense once I demo the binding part. So if I open Blob Trigger function itself, I can go to index.js, which is actually the main logic of the Azure of the function itself. In this case, all I'm doing is just I'm writing some records to the Cosmos DB resource. And I'm accessing this Cosmos DB resource by accessing the bindings object. Okay, and that bindings object is inside this function.json file. Okay, inside this function JSON file, again, we define the trigger, we define the binding. In this case, I have an HTTP trigger, okay, and I have an output binding of Cosmos DB. Okay, and as you can see here, it's type Cosmos DB and the direction is out, and we have a connection string called my account Cosmos DB, meaning when I run this function app locally, the connection string will actually be read from the local.settings.json. Okay, so that's different than when in the cloud. I'll show you how that gets read from the cloud, but in the case of running it locally, we read the connection strings from this local.settings.json file. Okay, so I can essentially run this locally, I can debug this locally, and I can do everything locally, essentially. And again, I can deploy this function itself to an Azure function app resource by using the Azure extension of Visual Studio Code, just like we did with Azure App Service. And we can also connect it to a source control repository like GitHub to have an automated deployment. Everything is exactly the same experience as Azure App Service, but the difference is this is a specific function. And if I go back to the portal, once I deploy these, I will actually see them under the functions blade. So as you can see, I have the Blob Trigger function and I have the HTTP Trigger function under this function app resource itself. And I can essentially test it from the cloud as well. So if I click on this specific function, I can go to code plus test, and I can test this specific function itself. So if I click on test/run, I can essentially run this, and you can see this should work. So saying thanks for reaching out, because this is the message that I've configured. So you can test things out here, etc. Now, the question is, how do we read that connection string that we have on the bindings file or the function.json file? Okay, if we go to configuration, we can see where the connection strings are actually configured. And you can see those connection strings here. So this is the my account _ Cosmos DB, which is used by the application. So again, we use the configuration under the settings here for any cloud deployments, and we use the local function.json file if you want to use the connection strings locally. Now let's talk about Azure Durable Functions. And Azure Durable Functions is a way to create complex orchestrations and workflows using code. So if you are familiar with a service like Azure Logic Apps, which allows you to create workflows using a GUI interface, Azure Durable Functions is exactly the same, as in it allows you to create those workflows and complex orchestrations, but using code. Okay, so traditionally, Azure Functions is actually a stateless system. So it doesn't make sense to store state in Azure Functions and use that state to make certain decisions in your code logic, okay? And the reason for that is because you don't have control over the instances themselves. Sometimes the instances spin up, they change from one instance to the other, so it's never a good idea to store state in Azure Functions, okay? The best practice is typically to use like an external storage like Redis cache, for example, if you want to store states and then make decisions based on those states. However, Azure Durable Functions makes it easy to create stateful functions, which allow us to create those complex orchestrations and workflows. And in fact, Azure Durables is actually, a durable function is not magic. It's just a library. So it's not a feature on Azure Functions. It's simply just a library that allows you to develop stateful functions. Okay, that's all it is. Nothing magic behind the scenes. Okay, so behind the scenes, the state is actually managed for you, okay? Now, this will make more sense once I demo this, but the common use cases when you wanna take state as an advantage is, for example, with function chaining, okay? So with function chaining, you can use an output of one function as an input to another function. Now, essentially, you need to store state with that. And with Azure Durable Functions, this makes it super easy, or this whole process is made super easy, okay? Now, the other common pattern is called fan out, fan in, where you can essentially execute multiple functions in parallel where you want to aggregate something, and then that aggregation is used in a single function, okay? Trust me, things like these are actually super difficult to develop, okay? So Azure Durable Functions make this experience super seamless. So things like fan out, fan in actually takes a long time to develop, and it's super complicated to actually get right, okay? So again, Azure Durable Functions, in a nutshell, it's just a library that allows you to write stateful functions, which can then allow you to write complex orchestrations and workflows, just like you do with Azure Logic Apps, which is GUI based. Now, what are the components of Azure Durable Functions? Again, this is just a library, and typically with Microsoft, we provide you those starter templates and you can build on top of these, okay? So in this example, I have an Azure Durable Functions taken from the Azure documentation. And in this example, I'm actually using the function chaining example, where I'm using the output of one function as an input to another function, okay? This is the file structure, and those are the components that make up Azure Durable Functions. So the first component is the orchestration functions. And the orchestration function is the function, again, from the name, it orchestrates things, okay? Now, the activity function is actually the function that actually contains the majority of the logic, okay? So in this case, it's hello one. Finally, we have the starter function, which actually starts the orchestration, okay? Now, the question is, how does all those three work together? So you typically have a starter function, which starts the orchestration function, and that orchestration function calls the activity function or orchestrates the activity function, which contains the majority of the logic. So if I go back to Visual Studio Code, I can see this is the orchestration functions. So as you can see here, I am using the first example of the durable function, where I'm using the input of one function as an output to another function. So in this case, I'm calling the hello function 3 times. Now, this hello function is actually the activity function, which is defined here under this hello one folder, okay? So essentially what's happening here is I'm calling this hello function and I'm providing Tokyo as an input. And then once that is done, I will call the hello again and then provided Seattle. And then once that is done, I will use this as an output to the third function, etc. Okay. And here, as you can see, this starter function, which actually starts the orchestrator. Okay, so that's the way this works. And behind the scenes, the state is actually stored on Azure Storage. Okay, so all of that magic actually happens on Azure Storage, all of those states, the execution history, and things like that. So last but not least, we have the final topic in Azure Functions, which is Azure Functions Custom Handlers. So custom handlers are just a way to run Azure Functions using unsupported languages by offloading that work or that process to an external web server. So this diagram is one that I took from the official documentation, and I think it explains it pretty well. So the way this works is the function host itself will offload that request payload to an external web server that's maintained by Microsoft. And the code is ran in that web server, and then the response payload is given back to the function's host, which must be able to parse that JSON and handle that response itself. So essentially, with this experience, you are not limited with just the supported languages that Azure Functions support. Okay, so you can develop with things like Go, Rust, and even Deno in the case of TypeScript. So really, the sky is the limit here, and it's basically the same experience as using a regular Azure function. And when you first create the Azure function, you don't have a choice of choosing an unsupported language, obviously. So typically the Microsoft recommendation is just to choose .NET Core as the stack, okay? And then Microsoft will take care of it. So you can essentially use custom handlers like Go, Rust, etc. Hello everyone. This video is part 2 of the AZ204 study Cram. So if you missed the first video, make sure to watch it before continuing with this one. And with that being said, let's just get into it. So starting with Azure Cosmos DB and developing solutions on Azure Cosmos DB, let me explain what is Azure Cosmos DB. So Azure Cosmos DB is a general purpose NoSQL managed database that is globally distributed. And notice that there are a lot of powerful words here and I marked them in bold. So let me go through them one by one. The first part is general purpose. And by general purpose, what I mean by that is Azure Cosmos DB allows you to store different forms of data that work for your business case and allows you to use different APIs to access this data. So you can use the standard SQL query API that you're always used to query the data. You can use MongoDB API to query the data using MongoDB. So if your applications are already leveraging MongoDB, you don't have to make any changes in the code, so you can still leverage that. And the same is true for Gremlin, Cassandra, and table storage, which I will go through in a bit. And the forms of those data are stored in either key value pairs, column family, documents, or graph database. So this is what I mean by general purpose. Typically, you will find a use case that fits your business need, and the fact that Azure Cosmos DB is actually a general purpose database means that it will satisfy those requirements. And the second part is that it is a NoSQL database. And if I want to quickly skim through the differences between SQL and NoSQL, SQL is just a standard database that we've all been used to. It's what is known as a relational database, and data is typically stored in tables with foreign keys that link to other tables. So it is very good with relational data. That's why it's called relational database, and you can perform many complex joins. But it's not really designed for scale. Now you can certainly do scaling like with sharding or partitioning, but it becomes a much more difficult exercise to do it in a SQL format. On the other hand, with NoSQL, it is actually designed with scale in mind. So with NoSQL, it's actually a non-relational database, and it's meant to store unstructured data. So not in tables, typically it's in a JSON document. And again, it is designed with scale in mind. And you have to remember that SQL databases has been around for a very long time. And when those were created, I don't think the creators had the idea or the notion that there will be potentially millions and billions of users on the internet. So it wasn't really designed with scale in mind. With NoSQL, however, this is generally known as the modern database, and it's actually designed with scale in mind, and it's typically much easier to horizontally scale those databases. And lastly, the part that is very important is that it's globally distributed. So there's a very neat feature on Azure Cosmos DB that allows you to replicate the database globally, which is very useful if you have users across the globe where users are going to connect to the closest proximity. Next, let me expand on the data model families in Cosmos DB. Remember, I spoke about the Azure Cosmos DB as being a general purpose database, and typically these are the data model families that we can store. So we have the documents, we have the key value pairs, we have the column family, and we have the graph family. The first type is the documents database, and this is actually stored in what is known as BASIN format or binary JSON, which is essentially like JSON, but it gives it more data types. And it is JSON, but it is structured JSON. So it doesn't obviously give you the same experience as a SQL database with structured data with a full enforced schema, but it still gives you that structure nevertheless. Next, we have key value stores, and this is obvious from the name. It's a series of key value pairs. Many popular databases use this kind of data store like Redis, Azure Table Storage, etc. And next we have the column family databases, and this is what Cassandra actually uses, and it gives you a very similar experience to SQL, and it actually uses a similar language called CQL, so with a C. And essentially this doesn't enforce a schema like SQL databases, but it still gives you a similar experience. So data is organized into rows and columns with actually column families, as you can see in this diagram. And last but not least, in Cosmos DB, we have what is known as the graph database. And with graph databases, data is actually organized into nodes, and there are a series of relationships between those nodes. So this is very useful for scenarios where there are many complex relationships between data. So think of Instagram, think of TikTok, where there are likes, there are followers, etc., and all of those have to be connected to each other. So this is when a graph database makes perfect sense. Next comes the section of choosing the right API. So how do you choose the right data store? How do you choose the right API? And the exam actually expects you to know when to use which API. And from my descriptions, you should be okay with the exam purposes, but we can certainly do other videos to expand on those much further. But for the purposes of this exam, we have just the standard SQL API. And this is actually the native service on Azure Cosmos DB. It stores document and uses the SQL API that you are just always used to. Again, this is not a SQL database. It just uses the SQL language to query those documents that are typically stored in BASIN or binary JSON. Next, we have the MongoDB API. And obviously, if your applications are already leveraging MongoDB API, then it makes sense to use this API. And this also stores document and obviously uses MongoDB APIs. Next, we have the Cassandra API. Again, if your application is already using Cassandra APIs, you can leverage Azure Cosmos DB as a managed service on Azure, and it stores column-oriented data. And we have also the Gremlin API. And with the Gremlin API, again, if your application is already using Gremlin, you can use the Gremlin API on Azure Cosmos DB, which stores graph format data. And last but not least, we have the table API, and this stores key value pair data and it actually uses the Azure Storage API. So again, if your applications are already leveraging Azure Storage API, but you want all those extra features in Azure Cosmos DB, your best bet is just to use the Azure Table API. Next, I want to talk about partitioning here really quickly, which is actually a very important concept in this exam. And before I touch on partitioning, I just want to explain the resource hierarchy in Azure Cosmos DB. And that always starts with a database account, which is the Azure Cosmos DB resource that you create on Azure. And underneath that, you have the actual database that you create under that Azure Cosmos DB account. And inside that database, you have a list of containers. So think of containers as tables in SQL databases. And inside those containers, you actually have items. So think of items like rows in a traditional database. So with that being said, if I want to move on to the next part, as you can see here, the database is split into obviously containers, which are like tables. And those containers are actually logically placed across different partitions that you define by a partitioning key. So for example, in this case, we have different key value data or different items stored under a partition key known as city. And this other one is known as, the partition key is known as airport. So with that, it makes querying much faster because you can always query across a partition key, meaning you can do things like querying for all items with the city of Paris, okay? And you can only do that by using partition keys. So it significantly increases the performance of your queries just because of the fact that you use partition keys. And with that being said, the choice of implementing which partition key actually becomes a major design choice in your application, because this is gonna significantly play a role in the performance of your database queries. Now, those logical partitions, which are defined by partition keys, are actually placed into different physical partitions, okay? So if I want to summarize that, you have a database and you have a series of different containers that are placed across physically separated partitions. And with that being said, we consider the container as the unit of scalability. So in Azure Cosmos DB, you don't scale the whole database itself. You actually scale the container via partitions. So you increase the partition counts and you place those containers across those partitions. So when you set the Autoscale features on Azure Cosmos DB, which I will demo that in a bit, you are actually increasing the number of partitions. And this is actually why NoSQL databases are much more powerful with horizontal scaling, just because of that partition factor. Now let me provide a quick demo on how you would interact with Azure Cosmos DB. So if you go to Data Explorer under the Azure Cosmos DB account, here you can see the series of databases and containers under those databases. So in this case, I have two different databases. The first one is called Application 1, and the second one is called To-Do List. And under those databases, again, we can create containers. Okay, so in this case, I already have two different containers, which are known as tables. But I can obviously create a new containers. So I can do that via the portal, or obviously, probably you will always create them using SDKs in your applications. So here in this case, I would just have to choose the database, and I'm going to choose the existing database, which is called To-Do List. And then I'm going to name it container 2. And again, this is where you define your partition key, which becomes a significant precursor to determine the performance of your application. And in this case, I'm just going to choose address. And here you can choose the autoscale mechanism. So it could be an autoscale or it could be a manual scale. With autoscale, obviously from the name, the Azure Cosmos DB resource takes care of the scale for you up to a maximum RU. Okay, and RU are actually known as request units in Azure Cosmos DB, and there's a certain baseline that defines the performance of an Azure Cosmos DB. So I think it's 1 RU equates to 1 kilobyte of writes and maybe 5 kilobytes of reads. I would have to check the documentation for that, but bottom line is the way we measure performance in Azure Cosmos DB is by RUs. Okay, and in this case, I'm telling it the maximum RUs per second of 4,000, and the Azure Cosmos DB is just going to do the scale by itself. Obviously, I can just do a manual scale where I can just define the RU by myself manually. But obviously, autoscale is always important because you can actually save a lot of money, because at the end, again, you are paying based on the RUs. So with that, you can actually save a lot of money if your database is actually not being accessed a lot. And with that, I'm just going to click on OK and give that a bit. And my container is ready. I can see container 2 here being created. And I can obviously create new items here. So from the portal, again, typically you would create all of those using SDKs in your applications. But I just want to demonstrate how that looks in the portal. Next, let's talk about how do you interact with Azure Cosmos DB in your own applications, because in the real world, you will barely create those containers or items using the Azure portal. You will most definitely create them in your own applications. And with that, Azure actually provides you with different SDKs depending on your programming language that you can leverage to interact with Azure Cosmos DB. In this case, I'm going to show how to interact with a .NET NuGet package. In this case, this is called Microsoft.azure.cosmos in .NET. And with that, we have the obviously the using statement where you have to import that SDK, which is called Microsoft.azure.cosmos. And after that, you would have to create the Cosmos client using that Cosmos client class from that NuGet package. And then after that, you would actually create the DB itself, or the database. Again, by convention, it's called DB. So you would create this database, and then from that database, you would create the container. So it's pretty standard if you're used to using Entity Framework or any other SDK for databases. This follows the standard convention, so it should be very easy to use. Now, the exam will not ask a lot of questions around this, but it is important to know how do you define this Cosmos client, which you can then use to create your database object and then a container object. Next, let's talk about consistency levels in Azure Cosmos DB. And before I talk about the different consistency levels, I just want to explain to you why do we have the concept of consistency. And again, the nature of Azure Cosmos DB is a distributed system because it places data into different physical partitions and different partitions across the globe as well. So we need to start thinking about consistency, meaning what happens when a client writes new data to this database? Do we wait for that data to be replicated across the globe onto all databases before that client gets the confirmation that, hey, you're good? Or do we not care about consistency and we can just write it across this database and we need that confirmation regardless if it's actually synced into the other databases or not? So this is the notion of making a trade-off between consistency and availability. And by availability, I mean that when the client receives the okay, that data is being replicated. Because when you start caring about whether the data has to be consistent and has to be replicated across the globe before you receive the confirmation as a client, okay, this will be subject to availability issues because you need to take into account the network failures that might occur and all of that stuff in a naturally globally distributed system. So with a highly consistent system, you are going to make a trade-off with availability. For a highly available system, you're going to make a trade-off with a consistency. Okay. Now, the way to solve this, obviously, is just to use one single database and not have many different distributed databases. But obviously, this is not the way it goes with NoSQL because by design, it's actually distributed across the globe and across different partitions. So we need to think about those consistency levels. And even with SQL, you have the concept of master databases and read replicas. You still have to think about those consistency levels, but just in a different format that is outside the scope of this exam. Now, the exam is not going to expect you to know about all the different consistency levels, to be honest, but I would expect the exam to test you into two main ones. Now, let me go through them, the 5 of them, and I'll explain to you what the 2 ones are. So the first one is the strong consistency, and it's actually one of the things that the exam is going to test you on. And this is the simplest one. Basically, this guarantees consistency as the data is replicated synchronously to the replicas. So once the client writes data to the closest database, the client has to wait until all the data gets replicated synchronously before getting the okay. Okay, so obviously that's going to compromise availability, but you will make sure that you get strong consistency before getting the confirmation that data is actually written. Next, it's going to go into less consistency step by step, but we have the bounded staleness. And the easiest way I like to think about this is that the reads themselves might lag behind the write, and you define the lag itself. So this is what is known as bounded staleness. Next, let's talk about session consistency, which is actually the default one. And if you don't have a specific business case, your best bet is to use session consistency, which is by far the most popular one because it makes a nice trade-off between those 2 factors. So in this case, the writer in a single session, okay, so the writer will always be in a session, and that session can be defined actually by a session token, meaning that different clients can actually be under different session tokens, but there's no need to get into that. But essentially a writer, which is under the specific session, is guaranteed to read the same data that they wrote, which is perfect, okay? I don't want to read data that I wrote that are out of order, okay? I always want to read exactly the same as I write, okay? And I don't need to ever read a stale version that is out of date, okay? Now, the rest of the clients, which are outside the session, may experience dirty reads, which is okay. They're outside my specific session. So this is what's known as the session consistency. And next we have the consistent prefix, and this actually guarantees that reads never see out of order writes, but not vice versa, okay? And lastly, we have what is known as eventual consistency. And again, this is very simple to think about. It just offers no guarantees whatsoever in consistency, okay? You get the best latency because as soon as you write to a database, you're always going to get the okay. So there's no latency. There's no waiting for the data to be replicated across all different databases. So you're going to get the best performance, but obviously at the expense of consistency. Lastly, I want to touch very quickly on the concept of change feed in Azure Cosmos DB. And the easiest way to think of change feed is that Azure Cosmos DB actually exposes certain events to the outside world, and we can actually use those events in our application logic, okay? An example of those events can be deleting a container, creating a new item, and many other different types of events. And in your own application code, you can listen to those events, for example, whenever a container is deleted, and you can do something based on that logic. Okay, and of course you can also use Azure Functions, which is actually natively built in, where you can also listen to events on Azure Cosmos DB and then do a specific things based on those events. So the simplest way to think about change feed is that it exposes events to the outside world that your applications can listen to. And it can be in your own code by using our SDKs, or you can use Azure Functions, which is just natively built in. Next, let's talk about developing for Azure Storage. And with that, the primary service that you will use whenever you are developing applications on Azure is Azure Blob Storage. And to start this off, I want to explain what a blob is. Blob is a piece of unstructured data like PDFs, files, logs, images, videos, etc. And you might counter me by saying, okay, we have Azure files that we can use to store files. So why do we have a blob, or when do we store files on blob versus Azure files? And the simplest answer to that is if you have legacy applications that are leveraging file system APIs, your best bet is to store those files on Azure Files, because it just gives you this native file system APIs experience. Okay. Typically, blobs are actually cheaper than files. So whenever you can store your files in blobs, that's much better. And obviously, if you want an experience where you want to share files across different nodes using SMB protocols, then you would have to use Azure Files, obviously. But for the purposes of your application, your best bet is to use Azure blobs, unless you are already using Azure Files, if you're using file system APIs in your legacy applications. And it can be very confusing to know what kind of storage account to create, because we just have so many different ones. So I just created this slide to help you out, which is actually just really self-explanatory. Next, I want to just talk about the resource hierarchy when it comes to Azure Blob Storage. Okay, so you typically always start with a storage account, and under that storage account, you have a container, and under that container, you store a series of blobs. Okay, so again, this is very self-explanatory, but essentially you would have a container, and under that container, you would have a series of different blobs stored under that container. So those blobs can be just log files, they can be PDFs, images, etc. Next, let's talk about moving blobs around. Now, how do you move blobs from one container to another, or from one storage account to a different storage account? And with that, Azure allows you to copy blobs to move them around. Now, on Azure, there is no mechanism that allows you to move a container, a blob from one container to another, or a blob from one storage account to another storage account. But what you can do is copy that blob, delete it, and then copy it to another container or another storage account. And there are three different mechanisms that you can follow to achieve that. The first one is just using Azure CLI, and this actually uses AZ storage blob copy, and it's actually asynchronous, which means that you can track the progress, you can cancel the operation, etc. And it's very easy to use. You just rely on the Azure CLI command. Now we have the AZ copy application, or the executable that you actually download on your local machines. And this actually provides more features than Azure CLI. So for example, restarts can be configured when there's a failure of copying that data or downloading that data. And the performance itself of downloading or uploading the data can be tuned to the local machine performance. So this is actually pretty neat. And lastly, there's also the .NET storage library. So this is a programmatic way to move blobs around. But again, this requires some code investments. Next, we have the concept of blob metadata. And every blob or every container on Azure can have metadata associated with it, which means that there can be some extra information that can be associated with that blob or container, for example, like location, last access times, etc. And you can then use that metadata in your own applications. Okay. The first example is system-defined metadata, and this is actually configured under the covers, and the examples are last modified time, public access level, etc., which you can always use as part of your logic in your applications and as part of the policies, which I'll explain further on. Next, we have just a user-defined, which are those that you explicitly define, and these are just a series of key value pairs set on a container or a blob. And here are two examples on how you would retrieve system-defined metadata and user-defined metadata. So in the case of system-defined, we are actually retrieving the container URI, the public access, and the last modified time. And in the case of user-defined, we are just retrieving all the metadata associated with this specific container. And again, obviously, we're accessing the key object and the value object, and we're just writing them down on the console. And if I want to quickly show you the experience in the portal, Under the storage account, you can go to containers, and if you click on any container, for example, this one, you can actually define your user-defined metadata. In this example, is just key value pairs that you can define. So notice that you can define this on the actual blob itself, or you can define it also on the container level. So if I click on those three dots, I can edit the metadata, and I can give it extra metadata that I can then use as part of my application logic. Next, I want to just quickly touch on the Azure Storage SDK, and this is the SDK that you will use when you want to interact with Azure Storage in your own applications. And this is a slide that explains the different classes that you will leverage. The most important one is obviously the Blob container client, which actually allows you to manipulate the actual Azure storage containers and their blobs. And this is actually the class that allows you to create blobs or containers. Next, I want to touch on the Blob lifecycle and policies that are used to manage those lifecycles. And with that, I want to briefly touch on different Blob access tiers. Now, the first Blob access tier is known as the hot tier, where you pay more for storage but less for usage. And that's why it's called hot, because you're actually accessing it a lot. So you can pay a lot of money if you're using this data a lot. And this is actually the default one when you create a general purpose V2 storage account. This is actually placed into a hot access tier by default. And next we have the cold access tier, where you pay more for usage but less for storage. And lastly, we have the archive, and this is self-explanatory, where this is used for storing data that is rarely accessed. So again, you pay a lot of money for archived data, but the caveat is that there's big delay in retrieving that data if you end up consuming it. So again, this is used for archival reasons, where you don't access the data that often. And we manage the life cycle of these blobs from one tier to another. Okay, so we can have different lifecycle policies where we can essentially, under certain conditions, place blobs from the hot access tier to cold access tier. So for example, if the last modified time is greater than 2 days, you want to move it, for example, from the hot access tier to the cold access tier, where you are essentially paying less for storage but more for usage. But again, because the last modified time is actually large, you are actually not accessing this data. So you can always define those kinds of policies. Let me show you the experience of creating those lifecycle policies on the portal. And with that, under data management, you have to go to lifecycle management. And here I have a policy created called remove after 30 days. Now, this rule is actually just a JSON document, and essentially you can define specific actions for that specific policies. And what I'm saying here is, if the modified time of that blob is greater than 30 days, then just delete it. Okay, so the action is actually delete. Now, you can certainly create those rules using JSON, or you can create them using the UI. So this is a very simple experience. Essentially, this is a very quick example. You can just provide the values using the UI. And for example, if this is more than 3 days ago, then you can either delete the blob, move it to archive storage, or move it to cool storage, because again, by default, this is actually placed into hot storage. Now, your best experience is actually to create it using JSON files, because in the documentation, we have many different examples of different policies or lifecycle policies. For example, you have moving aging data to a cooler tier. You have moving data based on last access time, archiving data after ingesting, expiring data based on age. So you want to delete data that is under a certain age, and you can delete data with blob index tags, etc. So we have a lot of different JSON policies that you can just essentially copy and paste to the portal where you can create it using JSON. Hello everyone, and welcome to part 3 of the AZ204 study Cram. If you missed the chance to watch the previous recordings, make sure to do so before continuing with this one. So let's get into it. Starting off with the Microsoft Identity Platform overview. So what do we mean when we say Identity Platform? Identity Platform is a service that's responsible for issuing tokens to users and applications. With Microsoft, just as we have Platform as a Service, Infrastructure as a Service, there's also what is known as Identity as a Service, which is a service that's, again, responsible for giving tokens to users and applications. Now, what do we mean by token? Tokens are base 64 URL encoded strings that contain information inside it, and it's typically access level information. So if I show you a very quick example on this screen, we can see this token contains information inside it, such as the name. Typically, this contains some access level information, for example, like files.read, files.write, etc. So when we say tokens, typically inside those tokens, we have access level information embedded inside them, and we typically provide those tokens as means to prove that we actually do have the access level. And if I want to show you a quick relevant example on this diagram, which is how you interact with the Azure portal, typically you have a user that is signing into the Azure portal, providing credentials to the Azure Active Directory. In this case, it's the identity platform. And if the credentials are correct, the identity platform will then give back an access token to the Azure portal, and then the Azure portal will use this access token to access the Azure resources. In this case, it's trying to read from a storage account. And if I actually want to show an example on the Azure portal, if I click on this alerts resource, my Azure portal is accessing the Azure alerts resource, and I would expect a token to be attached with the request that is getting or fetching those alerts information. And if I actually click on this API call, I can see there's a bearer token attached with the request headers. And inside that bearer token, there's access level information that the backend is reading to confirm that the portal, in this case, has relevant permissions to access the Azure resources, in this case, fetching the Azure alerts. And as I mentioned, all of those are known as authorization flows. Now, obviously, this diagram is very much simplified, but what we see here are known as authorization flows, and we have many different types of authorization flows depending on the client that has been used. For example, if it's a single page application, there's a specific authorization flow. If it is a native application like a desktop application or a mobile application, there's also a specific flow used there. And if it's a backend application, there's also a specific flow as well. And if I go to the documentation and I go under the authentication protocols, under Oauth 2.0, which I will explain more about in a bit, I can, for example, see there are many different kinds of flows, and those depend again on the type of client used. In this example, there's the Oauth 2.0 client credentials grant. And as you can see here, this type of grant is commonly used for server-to-server interactions that run in the background. In other words, this is where there's no immediate interaction with a user. And this is relevant to the example I mentioned about the PowerShell script that just deletes emails every night. All of this uses a protocol known as Oauth 2.0. Now, there are many different explanations about Oauth 2.0, so I'm going to try to provide you the simplest explanation. Oauth 2.0 is a way to grant an application access to resources without sharing secrets. Let me explain that in a diagram. So in the old days, without Oauth 2.0, let's say you built a very cool startup application called Automatic Twitter Tweeter that basically tweets on behalf of users. Now, in the old days, you can have the user simply share his username and password with your application, and then your application would simply use the user's credentials to post tweets on his behalf. Now, obviously, this is not ideal because we don't want users to be sharing their usernames and passwords with our applications to be able to access the Twitter API. And this is why Oauth 2.0 was actually invented, and it is a way to access those Twitter APIs without having the user sharing his username and password with our application. And the way this works is we would register this application on the Twitter identity platform, and then we would have the user logging in with his Twitter credentials, in this case, essentially interacting with the Twitter identity platform. So the Twitter identity platform will check the user's credentials, and if they are correct, it will give back an access token to my application, and then my application would use the token to post tweets on behalf of the user himself, rather than use the user's credentials. And I don't want you to be confused here because you can see that the user still logs in and still types his username and password, but essentially that interaction here is actually just with the Twitter platform. It's not with my application. So those credentials are actually only shared with the Twitter identity platform. And obviously they have to be shared because the Twitter identity platform still has to authenticate the user. So this is how this whole thing with Oauth 2.0 started. It was just a simple way for applications to gain access to third-party APIs like Facebook, Google, Twitter, etc., without having the user share his credentials with the application. And before I go further with this, I want to kind of distinguish between authentication and authorization. So authentication is the process that identifies the user, and authorization is the process that checks what permission that identified user has to a specific service. Okay. Now, what I've shown you here, this is actually an access token used for authorization purposes because we are using that token to access the Twitter APIs. But on top of Oauth 2.0, something known as OpenID Connect was built on top of it. And OpenID Connect actually gives you back an ID token, which is used for authentication purposes. So for example, when you log into Facebook right now, you will actually get back both an ID token and an access token. The ID token is actually used to identify you, to know who you are actually, and show you all the relevant profile information that's specific to you because you logged in. But with the ID token, there's also an access token, and that access token is used, for example, to access your friends lists, posts or images, etc. And going back to my slide, the output from an Oauth 2.0 flow is an access token, and OpenID was built on top of Oauth 2.0, and the output of it is an identity token, sometimes called ID token. Now, the question is, why is all of that important to our own internal applications? Now, the reason why this is important and the reason why having an identity provider is super important is, apart from just giving the convenience to users of having them log into an application using their third-party providers like Facebook, Twitter, etc., which actually provides a much nicer user experience because they can already use those credentials and they don't have to keep on remembering different usernames and passwords. I think the more important reason is you have essentially outsourced authentication and authorization to third-party providers. Now, you can certainly by all means in your own application store the usernames and password in a database and authenticate those users by checking whether the credentials provided match those that are in the database. But this is a lot of heavy lifting for you. So why not outsource this procedure to third-party providers and essentially just have users simply log in using their Microsoft accounts or Google accounts or Facebook accounts without you having to deal with the process of storing secrets in your database and then having to deal with all that security overhead. So this is why it's important to use identity providers for our own internal applications, both for user experience, second for ease of management, and third for security, because those big companies have all the large infrastructure and security measures implemented in place, and we want to take advantage of those. Let me now perform a quick demo. And before I perform this demo, I want to quickly explain this diagram. So with this diagram, I have an application hosted on a web server, and that application exposes payment APIs and orders APIs. And we want to make sure that we protect those APIs, meaning that only clients with the relevant token can access those APIs. So no one from the outside world can just randomly call those APIs without providing a relevant token. Now, there are many different ways of protecting an API. For example, you could use things like subscription keys, etc. But in this case, we want to integrate our application with an identity provider, in this case, Azure AD, in order for clients to be able to present us tokens before accessing our APIs. Now, the way this works on a very high level is we would first need to register the payment and order APIs on Azure AD app registration. So that's the first step. The second step is we need to expose the APIs inside the application registration. I will show you more about that in a bit. The third step is to register the client application on Azure AD with the relevant redirect URI. Again, I'll dive deeper into that in a bit. And the last step is to add API permissions to the APIs exposed in step 2. Now, before I go to the Azure portal, I want to show you the sample code that I have. And as you can see, I have a very simple Node.js application, and I'm protecting this precious/hello API with a bearer token. Now, as you can see here, there's some code that you probably maybe don't understand. This is using Passport library, but essentially with any programming language, you will most probably end up using libraries to perform such functionalities. So in this case, I'm protecting this hello API with a token, meaning that only clients who present a relevant token will be able to access this APIs, and I can actually prove it right now. So if I go to Postman and I try to access this API, I will actually get an unauthorized message no matter how many times I try. Now, unless I provide the right token to this API, otherwise it will not work. It will keep on giving me unauthorized. So let me now follow the steps I have outlined in the diagram I explained. And what I will demonstrate is actually Azure AD B2C. Now, the experience is very similar with Azure AD, between Azure AD and Azure AD B2C. The simplest way I like to think of the difference between Azure AD B2C and Azure AD is that Azure AD is typically meant for collaboration or for businesses or for internal employees. Azure AD B2C is typically for your consumers, typically for your own external clients. Now, when you're building applications, probably if it's a public applications, you want users to be signing up to your applications, public users. And this is typically where Azure AD B2C is used, more for consumers of your application. Now, following the steps I have outlined in the diagram, the first step is to always register the web APIs on Azure AD B2C or Azure AD. Again, the experience is very, very similar. Now, in this case, I have already done that, but if you go to new registration, you can just give a name for this Azure AD registration, and then you would choose those relevant settings that's relevant to you. So if I want to show you the one that I have already created, I would register this application, and I've just arbitrarily called it Web API-1. And the first thing I have to do is to always expose an API from this backend. Okay, so I'm exposing API from this backend. In this case, the API I am exposing is called hello, because this is the API I'm actually exposing. I'm just giving it the name hello with the scope name of hello. But typically here you would have things, for example, like files, files.read, for example. This is like a relevant scope name, but in my case, I just called it hello, just for simplicity purposes. But the point is you always have to expose an API here, and this will make more sense in a bit. So that's the first step. The second step is we have to register the client application that's actually going to use our API. So if I go back, I've already registered this SPA front end, and I've given it a relevant redirect URI. So if I go to overview and I go to redirect URIs, I can see I've given it this redirect URI, which is essentially the home page. And you typically have to give redirect URIs to your client applications, and redirect URIs are basically URIs that you are redirected to after you successfully authenticate. Again, this will make more sense in a bit. Now, what you need to do with this client application is you need to access the APIs that you exposed in the previous step. So in this case, what you can do is you can click add a permission, and then you can actually choose APIs that your organization uses, or you can do one that you created yourself. In this case, I've created those two APIs, but this is the one that I created in the previous step and that I exposed. So this is important because, and as you can see, I'm allowing permission on this hello API. And again, it is a delegated permission because the user is going to prompt that flow. Now, if I want to show you the client application really quickly, it's a very simple React application. If I click sign in right now, and actually before I do that, I'm going to open the browser tab. And if I click sign in, let me provide the credentials. So in this case, by the way, I've already done the work of just registering this user on Azure AD B2C, but you can always sign up, obviously. I just did this in advance to save time. So if I click sign in, okay, bunch of stuff are going to happen. Now, supposedly my client application, in this case, this browser application, should have gotten a token and should be using this token to call my protected API, the one that I was not able to call previously in here on Postman. Okay, so this is still going to give me unauthorized. Now, if I click call API, and if I actually delve deep into this one, I can see first of all, that I'm attaching this token. By the way, this is a success because if I click on preview, I can see this is giving me thanks for accessing my hello API, which is the message I actually want to return. And if I actually copy this token that the client application has used, and if I go back to Postman, and if I go back to authorization, I chose bearer token in this case. And if I just paste that, and if I send this now, this should work. As you can see, it is working and it's giving me back the relevant message. And if I actually tamper with this token by any chance, this will not work. Okay, it has to be the exact same token that I used. As you can see, it's giving me back unauthorized. So with this, I have essentially protected my backend API. And now only clients with the relevant token and those that are registered on the identity provider can access my API. So essentially I have locked in my API access and no one can access them except those who can provide the relevant token. Next, I want to quickly touch on shared access signatures or SAS tokens. And SAS tokens are tokens that provide granular access to Azure services. And examples of services are Service Bus, Event Hub, Storage Account, etc. So let's take Storage Account as an example. Let's say you have an application that's trying to access a storage account. You can obviously give that application the storage account key, but you don't need to give that application this key because with this key, the application can essentially do anything with that storage account. It can delete the storage account. It can read anything. The access is there for a long period of time. So it's not a very granular access. So that's why we rely on services like SAS tokens, which essentially provide granular access to Azure services. And if I show an example on the Azure portal, under security plus networking with shared access signature, you can choose the allowed services and then you choose the allowed resource types. In this case, I want my application to access containers inside that storage account. And then you would set a start date and an end date. And then after that, you would generate that SAS token. Now my application will use this SAS token to access containers in that storage account rather than giving it the storage access key, which essentially the application can do anything with. The next section in this exam is about Azure Key Vaults. Now, a vault in general is a service that allows you to store secrets, keys, and certificates. Now, secrets from the name are just secrets. Those can be passwords, connection strings, or any other secrets that you store in your part of your configuration in your code. Keys are essentially used for cryptography. It can be a public key or a private key. And lastly, there are certificates, and certificates are essentially encrypted public keys signed by a certificate authority. So usually certificates are used whenever you want to prove the identity of your application. Now, what is the benefit of using a service like Azure Key Vault or any centralized vault service? Now, the first reason is centralized, meaning that many applications can share this centralized vault rather than have each and every single application deal with their own secrets separately. So we can have a centralized store of secrets, keys, and certificates where many applications can access this store. The second benefit is that it's secure and it is protected by Azure AD RBAC, meaning that you can enforce strict permissions and access control policies on the actual vault itself. A next benefit of having a centralized service like Azure Key Vault is that you can easily monitor access and use. Maybe for audit purposes, you want to monitor how many times a secret is being accessed. This is done very easily using Azure Key Vault. And lastly, there's simplified administration with things like rotation. Now, whenever you are dealing with secrets, keys, etc., you typically want to rotate those keys or secrets. And with Azure Key Vault, this is made so much simpler where you essentially don't have to make any changes to your application code. And I will talk more about that in a bit. And if I quickly demo that in the portal, this is an example of an Azure Key Vault resource. And as you can see under settings, we have keys, secrets, and certificates. So if I go to the secrets section, I can choose to generate one manually. You can generate one from your own application code. In this case, you give it a name and value. This example is a key value pair. Actually, secrets are always a key value pair. In this case, I have a name of test-secret2, and I can click on that. I've previously created this just to save time. And notice that we have this secret value, and I can show that secret value. And accessing this secret value is done by this specific URL. Now, you might wonder, okay, what if someone gets a hold of this URL? Does that mean that he can essentially access this secret value stored in Key Vault? And the answer is no. That's why there is an authentication layer to Key Vault. having this URL does not necessarily mean that you will get access to this secret value. That's why there's an authentication layer. And with the authentication layer, there's typically two options. The first and the simplest option is using Azure Key Vault Managed Identity, which I will talk about in a bit. But with Managed Identity, essentially only your authorized applications are able to access this specific URL and authenticate with Key Vault. The other option is, without relying with Managed Identity, is to essentially just register your application on Azure Active Directory. You let your application retrieve a token, and then it would use that token to access this URL and then get back a secret value. So my point behind all of this is that there's an authentication layer behind Key Vault, and not anyone with this URL can access this secret. And if I want to go back to some other options, here under monitoring, you can set several alerts, metrics, diagnostic settings for audit purposes. I want to show you something quickly actually related to versioning. So right here, when I click on new version, I can provide a new secret for this name. So basically, the nice thing about this is that if I change the secret value, or create a new version for this secret, I don't have to update my application code. My application code will simply use this URL, and this URL by default will point to the latest version. So this is a very nice thing from Azure Key Vault, because you don't essentially have to make changes to your application code whenever you have new secrets or new versions of this secret. Now let's talk about interacting with secrets in your own application code. I will show this example using Node.js, but this is applicable to any other framework or language. Essentially, the steps are the same. You would have to import an identity credential, whether that's the default Azure credentials or a managed identity credential. And then you would import the secret client object from the Key Vault library. And then after that, you would essentially define this credential, because you will use managed identity in this case, and then we would create the Key Vault client using this secret client object, passing in the relevant credentials. And then after that, we would use the client.getSecret method to access this secret. Now, what about app configuration, which is actually a very small part of the exam? So Azure App Configuration is essentially a configuration store where you can store configuration files in a centralized place. Now, in your application code, you would typically have several configuration files. For example, in .NET Core, you would have the app settings.json. In Node.js, you would have several other configuration files where you can store things like, let's say, connection strings and other configuration information. So with Azure App Configuration, instead of storing that configuration in your own code, you would store it in a centralized place on Azure App Configuration. Now, this is best used with Azure Key Vault because there's native integration between them. So let's say you are storing connection strings in your configuration files on Azure App Configuration. Instead of storing the value of the connection string on Azure App Configuration, you would simply store a pointer to Key Vault, which actually contains the connection string, essentially keeping your secrets on Key Vault and just configuration specific information on app configuration. Now, Azure App Configuration stores data as key value pairs, and I will show that in a bit. If I go to this app configuration resource and under operations, I go to Configuration Explorer, I can see a bunch of key value pairs that I've already imported as part of my configuration file. And the way to import it is by going to this tab, and then you could choose the source service. In this case, it could be another app configuration service or from Azure App Services, or just a configuration file that you import. And I've already done this in advance, and this pre-populated all of those key value pairs. Now, the important benefit of using a service like Azure App Configuration is you essentially store your configuration in a centralized location. Again, many applications can leverage this centralized configuration file rather than managing different configuration across different applications. So this is a big benefit, in addition to things like auditing, same benefits as we discussed in Azure Key Vault, as well as security as well. Now, another neat benefit to that is you can rely on things like feature flags, which are essentially ways to make changes to your application without redeploying it. So let's say you are testing out if the green button is actually generating some traffic and you want to change this green button to red button. You can use feature flags to change this inside the configuration file. Because it is stored externally from your application code, you don't have to redeploy the code to see those changes and turn this button from green to red. So this is a very neat feature, and this is known as feature flags. And the way to interact with app configuration using code is you would define the app config from the app configuration library, and then you would define a connection string. In this example, we'd use a connection string to authenticate to Azure App Configuration, and then we would define the client, and then after that, we would simply get the configuration settings from our application code and use it in our application logic. Next, I will talk about managed identities. And before I talk about managed identities, I want to explain a world without managed identities. Now, a world without managed identities is where we essentially rely on connection strings, secrets, and SaaS tokens. For example, let's say we have a web application that is accessing a storage account using SaaS tokens. Now, the way for this web application to authenticate to a storage account means that it has to use secrets like connection strings or SaaS tokens in this example. So it still has to rely on some form of a secret to authenticate to storage account. Example 2 is, for example, when a web application is accessing a storage account using service principal, meaning that the web application itself is registered on Azure Active Directory, and then the application would use the client secret to get back a token from Azure Active Directory, and then would use that token to access the storage account. In example 2, you are still using a secret, which is the client secret on Azure Active Directory. So you still have to manage secrets even in the second example. And bottom line from both of those examples is, a world without managed identities is a world where you would have to rely on secrets to authenticate to Azure services. Now, a world with managed identities is essentially a world where an application authenticates to an Azure resource without relying on secrets. This is the beauty of using managed identities. Now, the more technical definition is that a managed identity is essentially a managed service principal assigned to a specific resource like Azure VM. So when you enable managed identity on a specific Azure resource, behind the scenes, it actually registers a service principal that is automatically managed by Azure, meaning that it deals with things like client secret rotation and all of that. So you don't have to worry about the actual service principal, rather than have you manually register the application on Azure Active Directory. Now, the steps to enable managed identities are, the first thing is you would create a managed identity on an Azure service like VM, for example, and then you would assign that identity read permissions on an Azure storage account, for example, and then inside that VM itself, you would call a specific URL to get back a token without relying on secrets whatsoever. As you can see, this is the special URL that is used here on this screen. Inside the VM, if I call this specific URL, I will actually get back a token from the storage account because I enabled managed identity on this specific VM. And lastly, the VM would then use the token to access a storage account. So essentially with managed identities, I have successfully configured the VM to access a storage account without relying on secrets like SaaS tokens, storage account keys, etc. And with managed identities, we have two types of managed identities. The first type is system assigned, and this is a one-to-one relationship between the identity and the resource, and its lifecycle is dependent on the resource, meaning that you assign this managed identity to a specific Azure resource, and if you delete this Azure resource, then the system assigned managed identity will also be deleted. So it is a one-to-one relationship between the identity and the resource. This is known as system assigned. The second is user assigned, and this is a one-to-many relationship where you can assign that same identity to multiple resources. Let me give you an example. So say that you have multiple VMs behind a load balancer and you want those VMs to access a storage account. Okay. Now you can by all means assign system managed identities or system assigned managed identities on each specific VM, or you can simply create a user assigned managed identity and then use this user assigned managed identity to apply it to all of the VMs. So it's essentially a one-to-many relationships rather than manually creating a system assigned managed identity for all of those VMs to access the storage account. Hello everyone. This is part 4 of the AZ-204 exam covering caching and application monitoring. So if you enjoyed this, please like and subscribe. And with that being said, let's just get into it. Let me start by talking about caching. So what is caching? Caching is essentially storing temporary information in a high-speed data storage system. So the keywords here are temporary and high-speed data storage system. And caching is used to increase the performance of your applications and decrease the load on the backend. So for example, when you use a web browser, some of the data that you retrieve from servers are cached locally on the web browser, so that next time you make the same request, this data is being retrieved from this temporary cache store in your browser, which would avoid those multiple round trips to the backend servers. So this is what caching essentially is. Now, the example I gave you is with regards to the web browser, but for backends, there's also an element of cache there. And the most popular database used for caching is known as Redis cache. So this is by far the most popular cache or data storage system. And to show a quick diagram on how Redis cache is typically configured in the backend, typically you would have a web server and a database. So the difference between Redis cache and a traditional database is that Redis cache stores data in memory or in RAM, while traditional databases store data in the disk. So when you have data stored in RAM, obviously it is much faster to retrieve this data. So this goes back to the definition of a cache being that it's temporary, meaning that it is in this case stored in RAM. So obviously you don't want to store long-term information in RAM. And at the same time, it is high speed. So when you are retrieving data from RAM, it is obviously much faster than retrieving it from disk. So this is the popular highlight of Redis cache. Now, this is the typical architecture as mentioned. And in this case, the client talks to a web server, which in turn makes a trip to the database to retrieve the data from the database. And once it retrieves the data from a database, it caches this data on Redis cache, so that next time the user, when he makes the same request, the server will not go back to the database, but will instead retrieve data from the Redis cache, essentially improving performance because this data again is stored in RAM, meaning that it is accessed much faster. Now, before going into any code examples, I just wanted to highlight that I installed Redis cache locally on my machine. Now, obviously in production, you would have Redis cache in a standalone server, but for demonstration purposes, I have it installed locally on my machine, and I will provide instructions on how to install Redis both on Windows and Mac in the description below. So once you install Redis on Windows, in this case, this is Windows subsystem for Linux. So that's why you see Linux in this case. So if I type Redis server, I open up the connection to the Redis cache. So now it's saying that it's ready to accept connections from me. So I will initiate those connections from a different tab. So if I type redis-CLI, this is the CLI that allows me to interact with the Redis store. So what I can do is I can use the standard Redis commands. Again, this is not a Redis course. This is more about Azure Cache for Redis and some of the functionalities it offers and the use cases behind using caching. But for this specific case, I just wanted to highlight that Redis cache is essentially a key value storage system, meaning that it simply stores key value pairs. It does not store JSON, it does not store tables, columns, etc. It simply stores key value pairs. Okay, so if I type, for example, set name, Abdullah, so it's giving me okay, meaning that if I go grab the key, I will get the value, which is Abdullah in this case. So everything is stored in key value pairs in Redis cache. So now that I have Redis cache open and ready to accept connections on this specific port, let me go through the code logic very quickly. Again, this is not a coding course, but I just want to explain the logic here very quickly. So anytime the user goes to this route, my application will make an API call to this endpoint. And once it retrieves data from this API call, I will cache, or it will cache the data on the Redis cache using this command, okay, for this specified number of seconds. And then after that, we'll return the response to the user. So the next time the user accesses this route again, my application will instead get the data from the Redis cache instead of making this API call again, okay, significantly increasing performance in this case. So if I want to run that and show you a quick example, so let's type node app.js. And if I go to Postman and if I send this request, notice how long it takes to get back those responses. Okay. In this case, it's 782 milliseconds. So now I would expect my application to cache this response in Redis cache so that next time I make a request, my application will actually retrieve data from the cache instead of making another API call. And let's test this and see how it goes. Notice how much time this is significantly reduced. So it's down to 5 milliseconds because my application is now retrieving data from Redis instead of making another API call. Now let's talk about Azure Cache for Redis. And this is something that you will be tested on in the exam. So you won't be tested on basic Redis concepts. You won't be tested on interacting with Redis through code. This is what you will be tested on in the exam, but I've just explained those concepts to give you a better idea on why Redis is used and in what scenarios it is used. So essentially, Azure Cache for Redis is a managed Redis cache on Azure. So it's a platform as a service on Azure, where you essentially don't have to manage the hardware, you don't have to manage any patching, securities, etc. All you have is just Redis on Azure that you interact with, and you don't have to worry about the underlying infrastructure at all. So this is what we mean by managed Redis cache on Azure. Now, we have many different pricing tiers when it comes to Azure Redis Cache. I just want to touch on them very quickly, but I think this diagram is self-explanatory. So the basic just runs on a single VM. The standard run on 2 VMs. A premium it's meant for high performance. You know, there's some extra features like lower latency, high throughput, etc. The interesting ones are actually the enterprise ones, and the enterprise ones are actually powered by Redis Labs enterprise software. Okay, so if you have maybe a license there, if you are already leveraging Redis Labs enterprise software, you can essentially host this on Azure, and it offers a lot of extra capabilities like Redis Search, Redis Blue, etc. outside the scope of this exam. And then there's also the enterprise flash, which is basically the cost-effective solution for the enterprise tier. So what are some of the features of Azure Cache for Redis? The first feature is that it is obviously managed, meaning that you don't have to worry about the underlying infrastructure, and this is actually a major benefit. The second benefit is that it is highly available. Third benefit is that there's automatic failover, so meaning that if a specific region goes down, there's automatic failover to a secondary region, so you can configure things like these very easily. And then lastly, you get the monitoring capabilities. You know, whenever you rely on a managed service on Azure, you get monitoring capabilities built in that you can then leverage as part of your monitoring strategy. So this is how the Azure Cache for Redis looks like in the portal. You get a couple of different settings. You know, some of the prominent ones are the scale, where you essentially seamlessly scale up to more powerful instances. You have things like geo-replication, for example, if you want to replicate your Redis cache across different regions. You have things like private endpoint, and you can integrate it with a firewall. Essentially, you can restrict specific IP addresses to talk to this Redis cache instance. And then there's, as mentioned, built-in monitoring capabilities with this insights feature that you can then create alerts based on them. Now I will talk about one of the most popular services that we use to cache content in, and that is Content Delivery Network, or sometimes referred to as CDN. Now, if you search the internet, you might find a lot of confusing definitions about CDNs, you know, being globally distributed, you know, increasing performance, etc. A lot of confusing stuff on the internet. So I'm going to try to come up with the simplest definition I can think of when it comes to Content Delivery Network. So a CDN is essentially a set of reverse proxies distributed around the world, and that's it. Okay, nothing more, nothing less. It is simply a set of reverse proxies distributed around the world, and we typically cache content on those reverse proxies. Okay, now those reverse proxies are distributed around the world to make sure that they are actually as close to the user as possible. Okay, so let me explain that in a diagram. Actually, this is typically the architecture that you will see with CDNs. Okay, so you essentially have a central server. In this example, the server is located in the UK, and you have many different clients distributed all around the world, especially if you have a global application. Okay, so this user can be based in Europe, this user can be based in the US, and this user can be based in Asia. And then you have a set of reverse proxies or CDNs distributed around the world. So you would rely on providers like Akamai, Cloudflare, who already have those infrastructures distributed all around the world. Okay, so now the way this works is that the user actually accesses resources from that web server via this CDN resource, okay? So let's say the user is actually requesting, for example, an image. If he wants to view his own images or images of his friends, etc., he will typically make an API call to the server, but that call will actually go through the CDN. And once it goes through the CDN, typically this content is actually cached on the CDN. So that next time the user visits this, tries to access the same resource, he will actually retrieve it from the CDN resource itself. Okay, so the CDNs are typically used to cache content closer to the users or as close to the users as possible. Okay, and you might ask, what are some of the things that we cache on CDNs? The answer to that is typically static content. Okay, so by static content, I refer to images, I refer to files, I refer to videos, it could be HTML files, CSS files, etc. And if you think about it, 90% of web traffic is actually static. Okay, so just because of the fact that you cache static content all around the world, you are significantly improving performance for your users. Okay, so that is like one of the major benefits of using a CDN. The second major benefit, and the benefit also related to performance, is not just related to caching, okay? Even if you don't cache things on the CDN, you still get performance improvements because the traffic route between the CDN and the backend is actually much more optimized, okay? So even if you don't rely on caching, you still get performance improvements if you just use a CDN, okay? Now, the third major benefit, or let's say the second major benefit onto using a CDN in addition to performance, is actually security. Okay, because you have those set of reverse proxies distributed all around the world, you are countering one of the most popular security attacks, which are DDoS or distributed denial of service attacks. Okay, the reason why this method or this architecture or using a cloud or using a CDN actually counters this this attack is because you don't have a central resource to attack. Okay, all of those proxies are essentially distributed around the world, so you don't have a centralized resource that clients can abuse. Okay, so by definition or out of the box, whenever you are relying on CDNs, you actually gain protection from DDoS attacks. So this is the second or the third major benefit of having a CDN. I'm not sure if it's the second or the third, but just in a nutshell, what you get is improved performance and improved security. The improved performance is through caching and through the optimized routing between the CDN and the backend. So this is the simplest definition I could come up with the CDN. It's essentially just a set of reverse proxies distributed around the world, and that's it. And obviously you can rely on Azure CDN if you want to implement CDN capabilities in your applications. Okay. Now there's two major things you need to be thinking about whenever you are dealing with CDNs on Azure or outside of Azure. And the two things are typically validation and duration. So with validation, what do I mean by validation is that whatever you have cached in the CDN, you want to make sure that it is in sync with what you have on the server, or it's not out of date. Okay, so let's say that you are caching a specific video on the CDN, okay, that you obviously retrieved from the server. What if this video got edited, it got deleted, etc.? It's going to become out of sync between the CDN and the server. Okay, so this is the validation part. And the way this is solved is by using something called e-tag. Okay, e-tag is essentially a unique string assigned to a resource, like an image, for example, on the server. Okay, and the way this works is that the CDN continuously sends calls to the server attaching this e-tag in a if non-match header. Okay, so this is an example of the e-tag, and if this e-tag is equivalent to the e-tag we have on the server, then we know that they are in sync and the cache is actually still valid. Okay, but if the e-tag sent by the cache is different than the e-tag we have on the server because the resource got modified, the server will actually give back a 200 response or 200 status code back to the CDN with the proper resource. Okay, so this is the way it works. It relies on what is known as e-tags, and it relies on the CDN continuously sending requests to the server with the if non-match header. Okay, and the second thing that you have to think about is obviously the duration. So with the duration, it's obviously how long do you want to keep content cached on the CDN. Okay, and this is simply set by the server itself, where it responds back to the CDN with a cache control header that determines how long the content should be stored in the CDN or cached in the CDN. Now let's talk about application insights, which actually forms a good part of the exam. And before I talk about Azure Application Insight, I just want to touch on what we mean by Application Performance Management, or APM software. Okay, APM is essentially a software that provides application level monitoring. Okay, so maybe you are used to the standard types of monitoring tools that monitor your infrastructure like CPU, memory, etc. With APMs, or Application Performance Management software, those are tools that provide application level monitoring. So they go deep down into your code and they can monitor your code stack. They can monitor exceptions. They can monitor the duration of the specific API calls. They can monitor dependency calls like calls to your databases, etc. So whenever you hear or see the word APM, this refers to tools that provide application level monitoring. And on Azure, Application Insights is the APM service. And if I want to go through this very simple diagram, you have a standard web server and you have a traditional database, and you are interested in collecting application level data from this application. Okay. And to do that, you need to rely on a service like Azure Application Insights. And this is the logo for Azure Monitor, actually. So the question is, how do you collect data from those running applications and store them on the Application Insights resource or on Azure Monitor? Okay. And the way this works is you would typically install a library inside your application. So it's just like any other libraries. And this library is responsible to collect those data and send them over through port 443 to Azure Monitor. So it's a very simple mechanism. It's essentially just a library. Okay. Some other tools rely on things like agents. Okay, you can install an agent, which is essentially just a software on your web server, and that software actually is responsible for monitoring your application to send it over to the cloud, whatever service you are relying on. If you're using Azure App Service, actually, this comes in a click of a button, okay, because Azure App Service actually has a pre-built agent already configured, and all you have to do is just click a button to essentially attach the agent that is already installed as part of the app service image to your app service, okay, or to your instance. Now, what you can collect with Application Insights is essentially exceptions, dependency calls, performance, traces, even custom events, etc. And once you collect this data into Azure Monitor, there's obviously a reason why you have this data in Azure Monitor, or there's a reason why you have this data in a centralized place. The major benefit or the major reason is to allow you to search through this data. Okay, so you have this data in a centralized place and you want to make sense of the data that you have. And for that, you need some search capabilities. And on Azure, we rely on what is known as Custo query language, which I will demo in a bit. The second major benefit to having centralized data in Azure Monitor is to actually action on the data. And by action, I mean creating alerts based on certain thresholds that are violated. Okay, so whenever you have data stored in a centralized place, it makes it very easy to search through this data, and it makes it very easy to respond to this data by creating alerting mechanisms. Okay, so this is essentially how Application Insights comes into play with your own applications. And if I want to show a very, very quick code example, by the way, I made a very detailed video on Application Insights that I will link on the video in the description below. It will be actually very useful for you to understand the service in greater details. But essentially, this is an example of Application Insights being configured on a Node.js application. And notice that all I have to do is simply just download this library called Application Insights, okay? And then all I have to do is just set it up with the specific instrumentation key and then call the method start, okay? So this instrumentation key is actually given from the portal, which I will show in a bit, okay? And once I set up Application Insights from my library, it will actually automatically collect information such as dependencies. So if I make calls to my database, it will automatically collect this data, and it will collect things like the response duration from the database to see where the bottlenecks are. It automatically collects requests to my server, so the API calls. It automatically captures exceptions. Okay, so if there are certain exceptions in my code or errors, okay, it will actually capture those and send them over to Application Insights. And something I want to touch on is the reason why we have this instrumentation key is we need a way to identify a specific Application Insights resource. Okay, so obviously every customer will have its own Application Insights resource, and the Application Insights resources are actually segmented by instrumentation keys. Lately, we have things like connection strings, but for the purposes of this goal, let's stick with instrumentation key. So every application insights resource on Azure will have a unique instrumentation key, and this is a way for you to identify your specific application insights resource. This is a key that you need to store in a secure place, because if I have your key, I can essentially send data to your application insights resource. So you need to obviously keep it as a secret. So with Azure Application Insights, this is what you get on the portal. Again, I made a super detailed video linked in the description below about application insights. So just make sure to check it out if you want to get more confidence in this area before the exam. So with that, you have the overview page, which essentially gives you some out-of-the-box metrics that you can look at. Some of the interesting things to look for is application map, for example, which essentially gives you a visual way of seeing the interactions that your application is making with other components. Okay, so in this case, my application is actually interacting with a MongoDB database, and it's actually interacting with an external API. And another interesting thing to look for is actually the failures tab, where you can check the most popular failures in your application, and you can drill deep down into those failures as well. So here you can see that you get some sample codes that resulted in those failures, so you can check the history that led to this specific failure. Then you can check things like performance. So again, it filters them by the duration. So you can check the API calls with the most duration, etc. And you can drill deep down into performance, just like you would drill deep down into the failures. An interesting thing that you probably will interact with is this search functionalities. Remember that one of the benefits of having your data stored in a centralized location like Azure Application Insights is you can search on this data. Okay, so you can type things like requests, for example, and you can get the history of all the requests that you have in the last 24 hours. And obviously, you can rely on the Kusto query language to drill down into specific data that you are looking for. But the nice thing about Azure is actually they provide you all of those queries out of the box. So if I click on queries in this example, I can check things like that I can alert on. I can check things like performance. So these are a set of queries that are created out of the box by Microsoft or by the Microsoft product group. That essentially saves you some time. You don't have to know the Kusto query language, which is, by the way, super easy to learn. But again, this will save you a lot of time. An explicit thing or a specific thing that was mentioned in the exam syllabus is actually availability tests. So if I go to this availability tab, essentially this tab allows me to create availability tests on my server. Okay, so essentially those are URL ping tests, meaning that the Azure Application Insights service from Microsoft will actually continuously ping your specific endpoints, okay, to check their health. Okay, so if your specific endpoints are not responding to those HTTP calls, then we deem them as unavailable. Okay, so this is why it's called availability tests. Okay, and this is a way to incorporate what we call health checks into your applications. By health checks, what we mean by that is that our service continuously pings your servers and maybe checks if the server will respond back. You can even go as granular as checking how long it takes for the server to get back to you, and then you can define a certain failure criteria. You can go as deep as checking if the content you get back from the server actually matches what you are expecting. Okay, so if I go to classic, add classic test in this example, I can give my test a name, and then here you would provide the URL of your application. So this can be the home page of your application, and this can be a specific health check endpoint in your application that does a specific check behind the scenes and gives back a response. It can be a lot of different things, and here you can define the test frequency, meaning how many times you want Application Insights to ping your server. It could be 5 minutes or up to 15 minutes. And then you can configure test locations, which is actually interesting. So you can test from many different locations all around the world. Okay. And lastly, obviously here you can define the success criteria. So you can define it based on a timeout. You can define it based on an HTTP response. So if you don't get back a 200, then you know that this is unhealthy. So we can flag it as unavailable, etc. And last but not least, you can also configure things like alerts. Okay, so here you can configure alerts out of the box, meaning that when this specific endpoint is failing, you can get alerts to be sent to you maybe by email, by even Microsoft Teams, etc. Hello everyone. This is the last part of the AZ204 study cram. So I hope you found a lot of added value from the previous videos, and I hope you find added value from this one as well. Please like and subscribe if you enjoyed this series so far. So let's get into it. So we will start off by explaining Azure API Management. And as usual, before going through Azure API Management as an Azure product, I always like to take a step back and explain the fundamentals behind a specific product. So with that being said, I want to explain what is an API gateway, or what is the fundamentals behind an API gateway. So an API gateway is essentially a reverse proxy with API features. So by reverse proxy, I mean it's from the client to whatever API that you have. So it is nothing more than a reverse proxy with API features, which I will talk more about. API features include caching, throttling, etc. And I will go into them in greater details. The second fundamental characteristic of an API gateway is that it has a developer portal that allows users to interact with your APIs through that portal. So the fundamentals behind an API gateway product is essentially just a reverse proxy with specific API features. And by design, it should have a developer portal to interact with the APIs. With that being said, let me now go through Azure API Management as a product. So with Azure API Management, this is the standard architecture that you will place your API management into. So what you have here is you essentially have a client. In this case, it's a mobile application. It could be a browser, etc. And those clients access your backend APIs through the Azure API Management resource. So essentially, this Azure API Management resource is acting as a reverse proxy to the backend APIs. And you can add a lot of extra features on top of that API management resource. Again, features include caching, throttling, even checking for the presence of specific tokens, etc. So this is usually how you will see Azure API Management in a standard architecture. So it's essentially a reverse proxy that interfaces with your clients. So your clients in this case do not actually access the backend APIs directly. They actually access the gateway itself. In this case, it's the Azure API Management product. And if I go through a quick demo on the portal, in this case, I created an API management service, and you have this standard view. The most important thing is the APIs section, where underneath it, if I go to APIs, this is where I define my backend APIs. Okay, so if I click Add API in this case, I can define my backend APIs through multiple different ways. I can simply do that manually by typing the actual HTTP endpoint, or I can upload an OpenAPI specification, which is actually the recommended way if you have a lot of APIs. Or you can simply onboard backend APIs from Azure resources. For example, if your backend APIs are in Azure App Service, you can put that as a backend. If it's a function app, it's the same thing, logic app, etc. So in this case, I've already created an API called Demo Conference API, and this is actually given from the Microsoft official documentation. So if I go through this Demo Conference API, I can see a bunch of different backend APIs defined. Okay, so for example, if I go to this Get Sessions API call, okay, I can actually make API calls to this session, to this API, but what the users access is actually my API management endpoint. And then my API management endpoint will make this HTTP call to this backend. Okay, so in this case, if I go to the test tab, I can see this is the actual request URL that my client should call. Okay, this is not directly calling this API. It's calling, again, the Azure API Management resource, which then calls this Get Sessions API. Okay, so if I copy this request URL and I actually test it out in Postman, and if I click send in this case, so this is telling me that access is denied to this specific API endpoint. And the reason for that is because whenever you onboard an API to Azure API Management, in order to effectively access it, you need to provide what is known as a subscription key. Okay, so this is a nice thing about API management. By default, it actually protects your backend APIs through subscription keys. So I cannot access this API unless I have a subscription key. I will go through API keys in a greater details later on, but essentially you can see under this test tab, you can actually easily test your APIs from this blade right here without using something like Postman. And the nice thing is that it actually auto-populates the subscription key in this case. So if I click send, I should expect to get back some result from this API. And as you can see, this actually worked. So you have a lot of different things that you can do under this blade, but I will get back to it in a bit. Next, you have something called products, and products is essentially a way to group APIs together. So that's all it is. So you essentially group certain APIs together that then forms a product. Okay, and the nice thing about grouping APIs together to form a product is that you can apply specific policies and subscriptions to a specific product, which has a lot of APIs underneath them. Okay, so with that being said, let me now go through what is known as subscriptions. So in this case, I've created a couple of different products. You have this one, for example, created by default. So if I go to this test product, I can go through the API section and I can see which APIs are defined underneath this product. In this case, I only have one API, which is the one that I demonstrated. And the nice thing about this is I can actually add subscribers to this APIs. Okay, so by subscribers, I mean you add specific keys that you give to subscribers, which that they can or they should actually use in order to access your APIs. Okay, so the nice thing about having products is that you can create subscriptions, different access control policies, and different policies. Now, with that being said, as you can see here, the access control can be applied to administrators. So in this case, it's myself, the person who created this Azure API Management resource, or it can be developers, and developers are essentially the users who are actually creating those APIs. Again, they're called developers. Guests are the ones interacting with your APIs. So they're not the ones who are administrating this Azure API Management resource. They're not the developers that are actually creating the APIs. They are the people who are essentially interacting with your APIs. Those are known as guests. And again, you can create specific access control policies to limit specific APIs, maybe to just developers, admins, etc. And going back to this designer blade and going back to the same API get sessions, as mentioned, the beauty about having an Azure API Management resource is that, again, it's a reverse proxy. But the nice thing is that you can apply extra features to this reverse proxy. And those extra features can be caching, they can be throttling, etc. So what I want to show you here is how you can add a throttling policy, meaning you want to limit how many times users access this API in a specific time frame. So as you can see, we have the inbound processing, we have the backend processing, and we have the outbound processing. So the inbound processing is essentially from the client to your Azure API Management resource. Backend is from your Azure API Management resource to the backend. And outbound is essentially the response before it is sent to the client. So you can manipulate certain stuff based on the position per se of the API. So in this case, I actually added a throttling policy to the inbound processing rules. And essentially, this is just an XML. And again, you can actually add them through those snippets, so you don't have to actually type it manually. So in this case, as you can see, I added this rate limiting policy. So essentially, this is telling me that I can only call this API for 3 times before it returns back a 429 throttling error. Okay, so if I click discard because I already created that, and if I actually test this policy, if I go here and I click send, let's click send again, let's do that again, and let's do that again. As you can see, now I'm getting 429 too many requests. And again, this is one of the major benefits of using Azure API Management, because not only it's a reverse proxy providing more security, meaning that your users don't actually access the APIs themselves. The nice thing about this is you can create those extra API features or extra API policies such as throttling, which is super important. And believe it or not, it's a bit tricky to implement using code. Now, the last thing I want to go through is actually the developer portal. And when you go to the developer portal and under developer portal overview, you can essentially go through this developer portal that users use to interact with your APIs. Okay, so in this case, once I go through that, I actually get a designer blade where I can actually easily design my or customize my Azure API Management developer portal. Okay, so essentially you can customize the sign up page, the Explore API page, you can change those APIs, etc. But in this case, once you actually make all of those changes, you go back to the portal and then you essentially publish those changes. Okay, so once you do all of those changes under that designer blade or this customization blade, you can essentially publish this API. And once the Azure API Management Developer Portal is actually published, you can actually navigate through it as a user right now. So not as an admin who's designing the API Management resource. And if I navigate to this URL that I copied in a private browser so that I'm not actually an admin, this is actually what it looks like to guests. So guests can essentially sign up. They can go to the APIs section. They can test our APIs, again, provided that they're actually subscribed to the API and can actually provide the subscription key. So this is essentially a portal that allows guests to interact with your APIs. And any Azure API management resource or any API gateway resource should provide this functionality out of the box, and Azure is one of them. So with that being said, after all of that discussion, what is Azure API Management? So it's essentially an API gateway service on Azure that is serverless. And by serverless, I mean you don't have to configure any compute. Everything is done automatically with regards to the compute power. And after all that discussion, what is Azure API Management? So firstly, Azure API Management is an API gateway service on Azure that is serverless. With serverless, again, what I mean is that you don't actually think about servers at all. Second is that or the benefits of using Azure API Management is that it provides capabilities like Autoscale, monitoring, subscriptions and all of that, that you might not get into a standard API gateway product. And with using Azure API Management, there are a lot of different pricing tiers, and this can get confusing sometimes. So as you can see, this is a slide that goes through every single pricing tier, from consumption to developer to basic to standard and to premium. The simplest way to think about this is that premium is essentially the only pricing tier that allows you to place your Azure API Management into a virtual network. And sometimes that becomes useful, especially if you are interfacing with your on-premises APIs, especially if you want to segregate your APIs from, let's say, internal APIs to external APIs. You need virtual integration, virtual network integration in this case. The other interesting one is actually the consumption tier, where you essentially don't get most of the features. Like, for example, the developer portal is not included. But the nice thing about this is that it's a consumption tier, and it's super cheap, and it's based on how many times you actually use the API management resource. And a lot of customers actually prefer this approach. But again, the caveat is that you don't get most of the features that you get with other pricing tiers. Next, let's talk about Azure Eventing and Messaging Services. And as usual, before going through the actual products, I want to explain the fundamentals that will help you grasp the concept behind creating those products. So with that being said, I just want to emphasize that I created a super detailed video on eventing and messaging and all the eventing and messaging services on Azure, which I will link at the top. And again, I would highly recommend viewing this video if you want to get more confidence in this space. But I will essentially summarize most of the things I have discussed. So before, again, starting with the actual eventing and messaging services products on Azure, I want to start by explaining some fundamentals, starting by the difference between an event and a message. And before I explain what the difference between an event and a message is, I want to explain why this thing actually exists. Okay, so in the past, the way for two services to communicate with each other, and by two services, I can mean two web servers, two microservices, two function apps, two Azure app services, whatever they are, the standard way of communication between them is simply through request response. So the server sends a HTTP request and then would expect a response back from the other server. Okay. After that, eventing and messaging was introduced, and essentially a different way of communicating between services. Okay. So the first way is by using events. And by events, you essentially have the sender emit an event to a specific entity, and then you would have a receiver receive that event from that entity. Okay, so the nice thing about this is that they are decoupling between the services. So this is the major benefit behind using eventing and messaging, is that there is some decoupling that happens, amongst other major benefits that I actually go through into greater details in the video I have linked previously. But essentially, events are data that a service emits with no concern of receipt. Okay, so the sender just emits that event and has no expectation on who is processing that event or whether that event is actually processed. And that's actually different from messages, because messages, data that a service emits and expects a confirmation of message processing. So two very different things. When you emit a message, you would expect and you would actually request a confirmation of message processing. Otherwise, you will re-emit this message again. So those are the key differences between an event and a message. And next, I want to talk about the difference between topics and queues. So a queue is essentially a one-to-one between the sender and a receiver. Okay, so the sender sends a message or an event, and only one receiver receives that message or event. Topic is different, where you have one to many between senders and receivers. So a sender can emit an event or a message. You can have multiple receivers of that same event or message. So this is the key difference between topics and queue. And the first service I want to talk about on Azure is actually Azure Event Grid. And Azure Event Grid is essentially an event routing service that relies on a push model. Okay, so essentially what it is that you would have specific senders emitting events to Azure Event Grid, and Azure Event Grid will route those events to subscribers. Those subscribers can be Azure Function apps, web apps, standard web servers, whatever they are. Okay, and this is typically used for near real-time scenarios because it's actually the only service on Azure that relies on a push model. Okay, this is different from other services which rely on pull model. Okay, so with pull model, you essentially have the consumer pulling events or messages from the entity, in this case Event Grid, or you can have a push model like Event Grid where you essentially have the entity pushing those events or messages to the endpoints. And if I go through a quick standard architecture of Azure Event Grid, you can essentially see that you have an Event Grid topic that you have specific senders emit events to. Okay, so in this case, I have an Azure Function app and I have a standard application web server sending events to this Azure Event Grid topic. And then that Event Grid topic will actually route or push those events to Event Grid subscribers. In this case, it's an Azure Function app and an Azure Web App. And if I go through the portal very quickly, you can see that I've created a demo-topic Event Grid topic resource. Okay, and if I go through that, actually I get the overview page. And the most important thing that you should know is that there are things such as access keys, which you need to use in order to emit events to this Event Grid topic. On the other hand, you need to also create Event Grid subscriptions. So those are like two different resources. And if I go through the demo of creating an Event Grid subscription, I can see that you can choose many different topic types in this case. Okay, so you can see you have Event Grid topics and you have a bunch of other topic types. And you might wonder, why is that the case? And the reason why that is the case is because on Azure, there are many built-in events that you can tap into. Okay, so with Azure Event Grid topics, those are usually custom events that you emit, for example, from a function app or from a web server, whatever they are. Those are actually custom events that you write. But on the other hand, you can actually rely on built-in events on Azure that you can rely on to push them to specific endpoints. Okay, so in this case, if I choose the Azure subscriptions example, and if I choose actually the specific subscription, I can see that I get those default event types that I can actually listen to. Okay. So in this case, if I actually go to the endpoint, and let's say I define an Azure function resource, this Azure function resource will actually get specific events, which is from the Azure subscription. Okay, so anytime those events actually happen, the Event Grid resource will actually push those events to Azure function, and then Azure function will actually process those events and action on them. But in this case, I want to actually choose an Event Grid topic because I want a custom event that I will actually emit from my applications. Okay, so in this case, if I choose the subscription and the resource group, and then I would actually find the demo topic, Event Grid topic that I actually created previously. Okay, so now the question is, how do we send events to this Event Grid topic? And this is a very simple code example that shows you exactly how to do that. Again, this is not a coding course, but sometimes when you see actually this, when you see this in action, it helps grasp the concepts much better. So the first thing you have to do is essentially define the topic key. Again, you need this key in order to send events to a specific Event Grid topic. And then you would obviously need to specify the topic endpoint, which you get from the Azure portal. And as you can see in this case, I'm simply emitting this event. And once I emit this event, I would expect the Azure Event Grid resource to push those events to the Azure Function App resource, which I configured as a subscriber. Okay. Next, I will go through Azure Event Hub. And Azure Event Hub is simply a data streaming service that streams events to consumers, and it is capable of handling millions of events. This will make much more sense if I explain it in a diagram. So as you can see, this is the typical diagram that you see with Azure Event Grid. So you essentially have sources or event emitters that emit events to an Azure Event Hub resource. And then you would have this Azure Event resource streaming those events to consumers. Okay, so think of it like a YouTube stream where you essentially have a video that is streamed to multiple consumers. Okay, so in this case, we would have consumers relying on pull model. So consumers essentially in this case continuously pull events from Azure Event Grid so they can process them and then do certain actions. Okay, and the nice thing about this is Azure Event Hub is actually capable of handling millions of messages. Okay, so it is actually very useful in big data streaming services. Okay, for example, let's say you have a bunch of IoT devices emitting data. You can actually emit those data to a centralized resource like Azure Event Hub, which actually then streams those events to different consumers that can then action on those events. Okay, and the reason why Azure Event Hub is actually useful is because, again, it can handle millions of messages. Your consumers might not be able to handle those influx of data. So that's why you need a buffer in between. In this case, it's the Azure Event Hub. And if I want to go through the resource hierarchy in Azure Event Hub, which I find very useful to explain, otherwise it gets a bit confusing, you essentially have the Azure Event Hub namespace, which is actually the Azure Event Hub resource that you create on the portal. Okay. And then underneath that, you have several different event hubs that you can create. Think of those event hubs as essentially topics. So your event emitters actually emit events to specific event hubs under an Azure Event Hub resource. And then you would have consumers listening to events from specific event hubs. And if I go through the portal very quickly, I have this Event Hub namespace resource. And underneath it, I can create different event hubs. In this case, this is the event hub that I've created underneath this namespace. And essentially here you have some of important thing that you need to take into consideration is this shared access policy, which you should actually use in order to emit events to this Event Hub instance so that you can have consumers consume events from it. And again, if I want to go through a quick code example of how someone would process events from an Azure Event Hub, this is typically the coding a structure with an Node.js application. So essentially you define a connection string, and then you would specify the Event Hub name itself. And then the consumer group, in this case, there's a default one. Again, I go through these in much greater details in the other video that I've linked above. And then here's the storage connection string, and then the actual container name. And then here you can see that this is actually the a function that allows you to process the events that are being sent to Azure Event Hub. In this case, I'm simply just logging the events that I am receiving from Event Hub, but in the real world, you would probably do some extra processing on those events that you receive. Next, I will go through Azure Service Bus. And Azure Service Bus is the messaging service on Azure that supports both queues and topics. It's essentially the premium version of Azure Queue Storage with a lot of extra features that we'll go through into greater detail in the next module. And this is the standard architecture that you would see with the Service Bus resource. In this case, it's a Service Bus queue. And as explained, this is a one-to-one example between this Azure Web App resource and Azure Function resource. So the Azure Web App resource emits a message to the Service Bus queue, which is then received by the Azure Function resource. Next, in this case, we have the Azure Service Bus topic. And again, you have, in this case, one sender and multiple receivers of the same message. And if I go through this Azure Service Bus resource, under entities, you can see there's queues and topics. So if I go to queues, for example, I can create a specific queue. And again, you would use this queue to actually send messages to in order for the receiver to get that message. So if I go to this test-queue, I can see there's a specific queue URL that I would need to use in order to emit messages to. Okay, and then I would have to expect a receiver to receive this message and confirm processing of this message. If I go back to Service Bus and if I go to topics, in this case, I can see that I have a test-topic defined. And the difference between topics and queues is that in this case, you have to define a specific subscriptions. Okay, so if I click add subscription in this case, all this is essentially just a name amongst different settings that you can configure. Okay, so in this case, I have a subscription called endpoint 1. And this will make more sense in a code example, which I will show in a bit. As you can see, this is a code example that you essentially use to process messages on a topic. Okay, so in this case, as a receiver, you would define the connection string of the Azure Service Bus resource. You would define the topic name that you're actually consuming messages from, and you would have to define the subscription name that we have just created. Okay, then after that you would receive the message. In this case, all I'm doing is simply just logging the messages that I receive. But again, in the real world, you would probably do some processing on that message. Last but not least, I will quickly skim through Azure Queue Storage, which is essentially the same as Azure Service Bus Queue, but the difference is that Service Bus Queue is essentially a premium version of Azure Queue Storage. So again, it is a messaging service on Azure that supports queues, and you would use Azure Queue Storage if you have very high storage requirements, and it actually supports more storage requirements than Azure Service Bus Queue. Now, you would use Azure Service Bus for advanced features like first in, first out of the messages. Okay, and I go through this into greater details into the video I linked. Other features that you can actually take advantage of when it comes to Service Bus is duplicate detection. This is something you don't have actually in Azure Queue Storage, and it allows you to use other advanced protocols specifically for messaging like AMQP rather than just using HTTPS in the case of Azure Queue Storage. And the benefit behind using this protocol, for example, is that it guarantees persistence of the messages. So it guarantees the delivery of the messages because it keeps on persisting, sending those messages.